Several minutes ago, during a conversation with the crew, Commander Dick Truly reported that they had completed the repressurization of the cabin with the nitrogen, and asked the flight controllers here in Mission Control to keep an eye on the gate valve in the waste containment system that has been experiencing a slow leak for the last few days of the mission. Truly also reported that other than that leak, the WCS has been working as designed. This is Mission Control. Today is a get ready to come home day on the orbiter. Crew will be doing flight control system checkout as they usually do before on the day before entry. Firing up one of the auxiliary power units and moving the aerodynamic surfaces. Make sure that all of that very important equipment works before re-entry early Monday morning. They'll also be engaged in a test of the tactical air navigation system to determine whether or not orbiting spacecraft can use that earthly aircraft navigation system. Good portion of the remainder of the day is taken up with stowing away all the equipment in its proper place in the lockers used during the flight, so that nothing is floating around loose when they get ready to come home Monday morning. This is Mission Control, Houston.
Challenger, Houston.
Go ahead, Houston.
Roger, we're about to lose the TDRS due to blockage. We will probably down mode to the S-band, but will be intermittent. We'll for sure get you at the car at 4 at 19 plus 20.
Roger, Houston, traffic speed.
Challenger, Houston, we have you back through TDRS for about 12 minutes.
Roger, Houston, loud and clear.
This is Mission Control, and it's Capcom Franklin Chang speaking with the crew.
Challenger, Houston, we're about a minute to LOS. We'll see you next over IOS at 1939. Challenger, Houston, we have you to the Indian Ocean for 7 minutes. Roger, Houston copies. We see the activation and the maneuver.
Okay. And everybody's eating breakfast, Brian, and I'm up here setting up for our Around the World TV recording. For Inco's benefit, what I'm planning on doing is using cameras Bravo and Charlie, and let him run, so if he would avoid panning and tilting those two cameras while during the time that we're recording VTR, I'd appreciate it.
Roger, we copy and will go.
Other than that, I'm going to leave the control, TV power control switch in command, so, you know, you can do what you like beyond that.
Copy that. Challenger Houston, I got a switch action on panel A7 for you.
Roger, go ahead.
Roger, on that panel, the MADS strain gauge switch should go to PCM enable.
Okay, MAD strain gauge is PCM enable.
Roger, and we're going to go LOS here in about 30 seconds. We'll see you next over Yargady at 1955.
Roger, is this Franklin?
That's right.
Thank you, Franklin. Appreciate it, and see you there.
Okay. Challenger Houston, we have you for 7 minutes over Yargady.
Roger, Franklin. We read you loud and clear.
Mission Control, Houston, 4 days, 19 hours, 56 minutes mission elapsed time. Challenger approaching the western coast of Australia over the Yargady station, orbit number 78. Commander Truly reported in the previous pass that they were moving to the minus Z local vertical position attitude, and that the crew was having breakfast. He also noted that they were setting up the television for the Around the World tour. They'll be doing some videotape recording of television from the spacecraft looking down at the Earth. This is Mission Control.
Challenger Houston, we're 1 minute to LOS. We'll see you over Aurora in about 3 minutes.
Roger, Franklin. See you then.
Mission Control, Houston, 4 days, 20 hours, 2 minutes mission elapsed time. Challenger in the gap between the range of the stations at Yargady and Aurora will be catching just the tip of the range of the station at Aurora in about 1 minute and 45 seconds. This is Mission Control.
Challenger Houston, we have you through Aurora for a very short minute, and we'll see you next over Tidris at 20 plus 20. Challenger Houston, we're about 20 seconds to LOS. We'll see you over Tidris at 20 plus 20.
Roger, Franklin.
Mission Control, Houston. Very little communication with the crew during its pass over the continent of Australia. Challenger now out of range of those tracking stations. And if we acquire through the tracking data relay satellite over the Central Pacific, that would occur in about 13 minutes from now. 4 days, 20 hours, 6 minutes mission elapsed time. This is Mission Control. This is Mission Control, 4 days, 20 hours, 20 minutes. We have acquisition through the tracking data relay satellite.
Challenger Houston AOS through TDRS for 48 minutes, and we're standing by.
Roger, Houston, read you loud and clear, and we're recording on the Round the World VTR tour. During the daylight, our daylight, we're going to be on camera Bravo, and then as it gets dark, going to camera Charlie.
Houston, copy. Challenger Houston. Challenger Houston with a note on the FCS checkout.
Roger, Houston, go ahead.
Roger, we recommend on the APU, on the FCS checkout to use APU number 3. And the start time for that test will be at 21:35. That will be the start time of the FCS checkout.
Mission Control Houston, 4 days, 20 hours, 34 minutes mission elapsed time. Challenger passing into the darkness now, crossing the terminator on orbit number 79. While Commander Dick Truly continues to run the cameras and the tape recorder, video tape recorder on his around the world video tour. About an hour from now, the Commander Truly and pilot Dan Brandenstein will begin their checkout of the flight control system. Those orbiter systems which are used on entry day Monday. They'll fire up auxiliary power unit number 3, which provides power to the hydraulic system for the movement of the aerodynamic surfaces. That'll occur at about mission elapsed time 4 days, 21 hours, 30 minutes. We're still receiving data and voice through the tracking data relay satellite. And the Challenger is about to make a pass over the continental United States, coming up on the west coast of Mexico at the present time. This is Mission Control, Houston.
Challenger Houston, we want to send you a cap update.
Roger, Houston, go ahead.
Roger, Dan, we'd like you to start now the APU steam vent heater activation.
Roger, in work. Okay, Houston, that's complete. Boiler controller power heaters alpha are on, and so are the controllers. And we just went overhead, Houston, and it looks like you got some pretty good weather down there again.
Roger, Houston, we're checking the data. Challenger Houston, we got some good TV coming down.
Roger, you're looking at the Cape from 120 miles up.
Roger that.
And Houston, Challenger, really looks pretty on the States tonight. The East Coast looks clear all the way up to the Norfolk area.
Roger that, Dan.
Houston, Challenger.
Go ahead, Challenger.
Roger, that start of the flight control checkout and APU start at 21:35. Is that the start of the TDRS pass when we come up around there next time?
Stand by, Challenger.
Okay, well, when we get there, we'll have to be all ready to go, and as soon as you get data and ready to start them, let us know, and we'll get them started then.
Roger that. Challenger Houston, we got a resolution on the STS checkout question.
Roger, go ahead.
Roger, I would like you to start part 2 first at 21:35 and complete that, and then do the part 1 at 22:05.
Okay, part 2 first. Sounds good. Y'all still getting downlink TV?
Negative, Dick, no downlink TV.
Okay. Well, we just recorded Orion rising.
Mission Control Houston, 4 days, 20 hours, 55 minutes, mission elapsed time. We continue to have voice and data communication with the Challenger through the tracking data relay satellite. Spacecraft is approaching the west coast of Africa now and is over the Dakar station on orbit number 79. During that recent pass over the continental U.S., we had some live downlink television from the Challenger, crew operating the cameras as they passed over the U.S. We saw what appeared to be some thunderstorms over the Gulf area near the Houston area, and then some the lights of the Cocoa Beach and Kennedy Space Center area as they passed over Florida. In about a half an hour, the pilot and commander will be involved in the checkout of the flight control system. They'll be using auxiliary power unit number 3 for that checkout.
Go ahead.
Mission Control Houston, 4 days, 21 hours, 12 minutes, mission elapsed time. Challenger passing out of range of the tracking data relay satellite. We'll pick up again in about 16 minutes over Yargati. This is Mission Control. Mission Control Houston, 4 days, 21 hours, 29 minutes. Standing by for acquisition of the Challenger through the Yargati station in Western Australia.
Challenger Houston with you through Yargati for 7 minutes.
Roger, Houston, we have you loud and clear.
You too, Dan.
And we just transitioned to 801, and Guy's getting ready to start his TACAN test, and in about 6 minutes we'll start the part 2 of the flight control checkout.
Roger, copy.
This is Mission Control. Challenger crossing the western coastline of Australia at the present time. A couple of minutes ago we had pilot Dan Brandenstein reporting that mission specialist Guy Gardner was, or rather Dale Gardner was proceeding with his TACAN system checkout. They're evaluating the use of the tactical air navigation system for vehicles in orbit, and that they were about to begin their flight control system checkout. This is Mission Control.
Challenger Houston, we're 1 minute to LOS. We'll see you at Hawaii at 21:57.
We'll go, and we're on page 7-17.
Roger, thank you, Dick.
This is Mission Control. 4 days, 21 hours, 36 minutes, mission elapsed time. Challenger has passed out of range of the Yargati station, and it will be about another 18.5 minutes before we reacquire through the tracking data relay satellite on orbit number 80. Should that not be available or operating at the time we pass within its range, it'll be another 2 minutes after that, or a minute and a half after that, before we acquire communication through the Hawaii station. This is Mission Control.
Challenger Houston with you through Hawaii for about 2.5.
Roger, Houston, loud and clear, house.
You're loud and clear also, Dick.
And we've completed part 2. We had a couple of, not anomalies, but minor differences in the dedicated display check we can tell you about.
Roger, you can go ahead.
Okay, on the load test, the CDR's velocity read 20,040 feet per second rather than 20,000, and the PLTs read the same. Also on the load test, both HUD tests, in addition to what's on the picture, also have an indication of 20 knots in the airspeed location, which is not on the page in the orbit ops checklist, and I imagine that's flight data file. In the high test, the CDR's altimeter read 304,000 feet rather than 300,000, and the PLTs on the same test read 308,000 instead of 300,000. Other than that, the entire part 2 was okay.
Roger, we copy, Dick. Thank you.
And Houston, CDR, other than going to the big jets on page 7-10, we're waiting for your go on page 7-11 for APU start.
Roger, Dick. We'll give you that when we get AOS Buckhorn.
Roger, understand.
And we're about 1 minute to LOS here at Hawaii. We'll see you at Buckhorn at 22 plus 05.
You bet. See you there. We'll be ready.
Mission Control Houston, 4 days, 22 hours, 0 minutes, mission elapsed time. Challenger passing out of range of the Hawaii tracking station on orbit number 80. Dick Truly on that pass reported that they had completed a portion of the flight control system checkout. Noted some minor discrepancies in data readouts during that test, and they will be waiting for a go for start of their auxiliary power unit number 3 as they get within range of the Buckhorn station over the continental U.S. so that the ground controllers can see telemetry on the operation of that APU. Mission Control Houston, 4 days, 22 hours, 4 minutes, mission elapsed time. We'll be picking up over the Buckhorn station in about 20 seconds. At that point, Commander Dick Truly and pilot Dan Brandenstein will be engaged in the APU start or the checkout of the flight control system.
Challenger Houston with you at Buckhorn, and we're go for APU start.
Roger, Houston, it's in work.
Roger.
This is Mission Control. The crew is proceeding with APU start and driving the aerodynamic surfaces with the hydraulic system, which is given its power by the auxiliary power units. There are 3 APUs on board the orbiter. These are used to provide power to the hydraulic system, operate such things as the aerodynamic surfaces, the landing gear actuators, and the main engine thrust vector control on ascent. The APUs are powered by the decomposition of hydrazine. The hot gas that is produced by that decomposition is piped across turbine blades and drives the APUs at speeds of 72,000 RPM, and that produces 138 horsepower on each of those APUs.
Houston, CDR, on channel 2 of the negative stimulus, I failed to do the item 19, went to override once back to auto, and so GNC will know where we are. We're on getting ready to test channel 3. That was no anomaly.
Roger, copy. Challenger, Houston, we're going to go in a keyhole here, pick you back up a mile in 1 minute.
Challenger, copy. Houston, Challenger, how do you rate?
You're loud and clear, Dick.
Roger, the part 1 was nominal. We're waiting for your go for APU shutdown.
Challenger, Houston, Dick, we didn't see any Delta P's build up on channel 2 in the positive test. We'd like you to redo that.
Okay. Okay, here it comes, Houston.
Roger.
Okay, I'm waiting for your go to do the stop on channel 2.
Your go to stop, it looks good.
Okay, Houston, that's complete. Stand by for your go for APU shutdown.
And Challenger, your go for APU shutdown.
Will come. Okay, Houston, APU shutdown is complete, and we're back on 7-25. It's okay with you, and we're heading back for Ops 2.
Roger, stand by, Dick. And Challenger, Houston, Richard, we'd like to stay in Ops 8 here to finish getting the TACAN data, and we can go back to Ops 2 there at the when you maneuver to the minus the star tracker attitude at 22 plus 50.
Sure, I forgot about that, sorry. We'll do that. We'll remain here, and when guys through with the TACAN data, we'll head back to Ops 2 at ZLD.
Roger.
This is Mission Control, 4 days, 22 hours, 17 minutes mission elapsed time. Crew has completed their checkout of the flight control system. They just recently operated the auxiliary power unit number 3. That provides power to the hydraulic system and moves the aerodynamic surfaces. All of that system checked out properly, and they have shut down the APU. This is Mission Control.
Houston, Challenger.
Go ahead, Richard.
Yeah, I had a bet a nickel that after Dan shut down the APUs that I had gone to verniers, and now we're back in the big. I noticed we're in the big jets. Did GNC see us go to verniers?
Stand by. Roger, we concur. You went to verniers there, no problems.
Roger, well, verniers is where we should be, isn't it?
Stand by. That's affirmative. You should be back in verniers now.
Okay, I'm going to verniers. I'm not sure how we got back on the normal jet.
Okay, my misunderstanding, Dick. Your concern was you didn't know how you got onto norms.
That's correct. Yeah, I put in the checklist. I went to the vernier jets, and then after 3 or 4 minutes, a big jet fire, and I looked down, we were in normals, and I'm not, maybe somebody bumped the switch, I'm not sure, but just wondered.
Roger, we'll look see if we can figure it out from the data.
Roger. And Houston, CDR, we have powered down the switches on 7-25, except for the ASAs to keep the arrow drive messages off. And we'll catch the ASAs when we transition to Ops 2.
Roger, copy, Dick. And we're about to go LOS here. I'll see you at the car at 22 plus 29.
Roger, see you there.
Roger, and for Dale, be advised I've got a cap update. I'll be adding a VTR playback here of the orbiter inspection that y'all did yesterday. We'd like to dump that data, and I'll get that to you at Dakar.
Okay.
Mission Control, Houston. We have loss of signal through the Bermuda station. We'll pick up again in 5 minutes over Dakar. 4 days, 22 hours, 24 minutes, mission elapsed time. This is Mission Control, Houston.
Challenger Houston with you through Dakar and Ascension for 9 minutes.
Roger, Houston, and looking at the timeline, if we're to stay in Ops 8 to let Guy finish his TACAN test, we're going to be unable to maneuver to the Star Tracker attitude, so maybe it would, well, we can either zip back to Ops 2 and maneuver there and lose a little bit of the TACAN data, or just reschedule it later, and it's your call. Either way is fine with us.
Okay, stand by while we check it.
And, no problem fitting it in later on today if you'd like to do that.
Okay, stand by, Dick. And Dick, the way we had it planned was that the TACAN test would terminate at 2250, and then that's when you start your maneuver to the -C Star Tracker attitude.
Roger, Houston. I guess I'm confused in the, we've got our TACAN message that we got shows TACAN activity going all the way to 2327. It was my understanding we couldn't do that except in Ops 8.
Oh. Stand by, Dick. We see your confusion now. We're trying to straighten it out down here.
Okay.
And Challenger Houston, what we need to do on the your TACAN message is to delete those last 4 sites there starting at 2307, and we'll terminate at the 2245.
Okay, I understand. We'll do that, and we'll at 2250 we'll go ahead and do the maneuver and do the Star Tracker test.
Roger that. And I've got whenever you've got the time, we're going to try to get a VTR dump after lunch this afternoon, and we show a good time to set up the VTR setup for the playback would be right before lunch, and I've got some specific times for you whenever you want them. And Challenger Houston, we got a new state vector on board.
Thank you very much, and ready to copy the times you'd like the VTR done.
Okay, at first of all, at just before lunch at 5 days 1+20, we'd like you to perform the VTR playback setup. That's the photo checklist, page 1-31. And then at Hawaii AOS at 5 days 2+23, we'd like to perform the VTR playback. And then at 3+00, perform the VTR deactivation. And let me make a correction to the Hawaii AOS time for the playback. It's 2 hours and 37 minutes.
Okay, be ready at Hawaii at 2+37 for the VTR playback, and assuming you want to, or do you want to start that playback from the beginning of the underside survey?
Stand by. That's affirmative, Dick.
Okay, we'll be ready.
Challenger Houston, we're about 30 seconds till LOS. We'll see you at Botswana at 22+46.
Roger, Houston, see you there.
Mission Control Houston, 4 days, 22 hours, 38 minutes, mission elapsed time. Challenger out of range of the Ascension Station. Orbit number 80. And we'll hear from the crew again over the Botswana station in about 7 minutes. This is Mission Control.
Challenger Houston, I'm with you on TDRS now.
Roger, Houston, reach you loud and clear. And Houston CDR, I've got a question on the Star Tracker test.
Go ahead, Dick.
It has to do with the COAS. I'm assuming by make COAS observations that you don't mean do any maneuvering or anything, but just look through the COAS and see if we can record the location of the star in the COAS and mark that down so we can tell you about it. Is that correct?
That's correct, Dick.
Okay, no problem.
Okay, and I got a little note for you on that. If the when you try to break track on a real bright object and it doesn't, you don't lose the asterisk, as happened the other time you did this, we suggest that you do an item 8 about every 15 seconds until it finally does break track.
Okay. The first time that it happened yesterday or the other day, whenever that was, I did do several item 8s, and it seemed to break track on its own, later on, and so after that I kind of gave up, but we'll try that again.
Okay, yeah, that's correct.
And what appeared to me as it to be happening was is that the star just exited the Star Tracker field of view, and that. But who knows?
Yeah, we concur with that, Richard, but GNC was suggesting that about every 15 seconds you can try it again, and if it doesn't work, then it will finally break lock when it leaves the field of view again. Challenger Houston, we broke lock on TDRS halfway through my response for you. Did you copy all of it? We're back with you.
Houston, Challenger, how do you read it?
Reading you loud and clear, guy.
Okay.
And Challenger, we're very intermittent on TDRS now. I'll have you at Botswana in about 2 minutes.
Roger, Houston.
Challenger Houston with you through Botswana for 4 minutes.
Roger, Houston, reading you loud and clear.
You're loud and clear also, Dan. Challenger Houston, we're 40 seconds LOS. See you at Yargadee at 2303.
Roger, Houston.
This is Mission Control, 4 days, 22 hours, 50 minutes, mission elapsed time. We have loss of signal through Botswana. We'll pick up again in 13 minutes over Yargadee. This is Mission Control.
Challenger Houston with you through Yargadee for 6 minutes.
Roger, Houston, we got you loud and clear.
Roger, you too.
And Houston CDR, we're on the way to the Star Tracker test attitude.
Roger, copy. Thank you, Dick.
Houston, Challenger.
Go ahead, Challenger. Dan, go ahead.
Roger, Guy. I made a little slip up this morning. I missed the HRM activation in Dale's column, and I was getting ready to possibly do it in the near future, but maybe those guys have an optimum time. They'd like to try it sometime later today, and if you check with them, I'll do it as soon as I can, or if they have a time they would like it done, you can send that up to me.
Okay, we'll work on that.
It was originally scheduled, looks like, for about 20:45.
Okay, Roger, we'll look at it. Challenger Houston, we're 40 seconds to LOS. We'll see you at Hawaii at 23 plus 28.
Roger, Houston, and we were about 3 minutes late getting in attitude. We're in attitude now with the shutter open and have not gotten an asterisk yet.
Roger, copy, Dick. And it looks like we found out why you went back to normal jets, but it's something I don't have time to talk about now. We'll get to you later. It was just a funny in the way the software works.
Okay, well, I appreciate you checking, and we can talk about it later. Thanks.
Mission Control Houston, 4 days, 23 hours, 10 minutes, mission elapsed time. Challenger passed out of the range of the Yargety station. During that last pass, Commander Richard Truly reporting that they were proceeding with the Star Tracker acquisition test. We have about 18 minutes before we reacquire again through Hawaii. We could pick up the tracking data relay satellite after we leave Hawaii. That would be in about 24 minutes. This is Mission Control, Houston. Mission Control, Houston, standing by for acquisition through Hawaii.
Challenger Houston with you through Hawaii for 5.5.
Roger, Houston, loud and clear.
Roger, you too, and I've got a new time for the HRM activation when you're ready.
Okay, ready to copy.
Okay, we'd like to activate it at 5 days, 2 hours plus 30, and deactivate it an hour and a half later at 4 plus 00.
You guys got the times 2 plus 30 activation and 4 hours deactivation.
That's correct, and I've got some words on that, the DAP up mode into normal jets when you're ready to listen.
Okay, go ahead.
Yeah, it seems you were quick on the MLS switches and you turned all 3 of them off simultaneously, or at least within one data cycle, and that caused a temporary comm fault. And when the DAP saw the comm fault, it went to free drift. And then when that was cleared on the next data cycle, the DAP, when it comes back, comes up in normal jets. That all happened in 40 milliseconds.
Okay. Another little trap, I reckon. Thanks for checking. That's interesting information. I'm glad to know, because I was sure confused.
Roger that. And that's being fixed by a CR, by the way.
Okay. Appreciate it. And we've hit sunset now, and I'm going to go ahead and get started back to attitude, and then I'll give you a report on this test.
Roger.
Okay, Houston, CDR on the Star Tracker acquisition test, the second one we did. During the period of time that we at our first got to attitude until now, we only got 4 stars to show asterisks in the table. On each one of them, I attempted to break lock with the item 8 again, and I did it a number of times on each one. However, just subjectively, it looked like it was still random, and it just stayed there until it decided to go away and went away. And unfortunately, in the COAS observations, Dan, it was just too bright for Dan to see any stars at that low angle. So we got the data on 4 extra stars, looks like.
Roger, copy that, Dick. Thank you. Challenger Houston, we're about 1 minute to LOS. We'll see you at Buckhorn in 4 minutes.
I just see you there.
Mission Control Houston, 4 days, 23 hours, 36 minutes, mission elapsed time. We have lost a signal through Hawaii, and we'll pick up again over the continental U.S. in about 2 minutes. During that recent pass, Commander Dick Truly discussing the procedures with the Star Tracker acquisition test. This is Mission Control. This is Mission Control, standing by for acquisition through Buckhorn.
Challenger Houston with you through Buckhorn for 6.5.
Roger, loud and clear.
You too.
And Houston CDR, I got a question on scheduling for the RMS glow and the tail glow DTOs.
Roger, go ahead.
Raj, in looking at the way that they're laid out, it looks like it's going to be a bit of a rush between 0102, which is availability time of the RMS glow, and 0122, which is the end of the availability of the tail glow. To get them both accomplished and change the cameras, we can probably do it. Would be a little bit of a rush. What Dan and I were thinking about suggesting to you was that we schedule the tail glow down at that next night pass at about a time of 20:02:35 or something like that, and do the RMS glow where it's scheduled, and then do the maneuver and the tail glow during that next night pass, and we'll shift our meal with no problem to be able to get both of them.
Okay, stand by, Dick.
Okay, it's no problem. We can try it the way it is, but I think we'd have a better success if we could split them up a little bit.
And Dick, your plan sounds good to us.
Okay, why don't you take a look at the details of it and get us when you would like us to maneuver to the tail glow and what the new availability is, and we'll plan on doing it that way. Appreciate it.
Roger, Wilco.
And Guy, also, I wonder if you could, I've got a comment on Earth observations, if you could pass to the Bob Stevenson or the one of whoever's the oceanographers that are working today.
Okay, go ahead.
I reported yesterday that the Agalhas current, which is between East Africa and Madagascar, was very quiet, and we couldn't see anything in the glitter patterns, and we just crossed over it on the last rev, and I don't know what has happened between yesterday and today, or whether it was cloudy or whatever, but it was really spectacular. A lot of spiral eddies and fronts, and we think we recorded it.
Sounds great, Dick. Thank you. We'll pass that along.
Okay, thank you.
And Challenger Houston will be leaving Buckhorn here in a minute, handing over to Tidris.
Roger, Houston.
Challenger Houston with you for on TDRS for about 30 minutes.
And Houston, CDR, we just handed over to teachers from the Buckhorn station, didn't we?
Roger, that's affirmative. We're on TDRS now.
Their support, I understand that Buckhorn is not going to be up for future shuttle missions, and they have done such a super job through all the shuttle DDT&E flights and the first operational flights, and the STS-8 crew would just like to pass them a well done.
Roger, thank you, Dick. We'll pass that on to them.
You bet.
And Challenger, I've got one message here on one last test on the tag system whenever you're ready to listen.
Okay.
Okay, what we'd like to do now is one last thing, just for some data, is to expose the paper by having you open the access door for about a minute, and then we're just going to run it through the developer after it's already been exposed, and you won't need to do that to monitor it at all after that point. So we'd like you to go down and open the paper access door for about 1 minute, and then reclose the door and secure it.
Houston, CDR.
And I heard your last call, Dick. We're dropping in and out on TDRS.
The CDR.
And Challenger Houston on UHF through Mila, we're having very intermittent locks on TDRS.
Jeff, Pat, talking about the open tags access panel for a minute, but then you cut out kind of the... Also, it almost slipped my mind that we had not done the RCS hot fire test, and if it's okay with you, we'll just get it as soon as we can.
Roger, we're ready whenever you are.
Okay, give us a couple, 3 minutes, and we'll get on it.
Okay, in the tags test, all I needed someone to do, Dick, was to open the paper access door for about 1 minute and then re-secure the door, and then we'll just take care of the rest. You don't need to worry about it.
Okay, Dale's on his way downstairs, and he'll open the access door for 1 minute and then secure it.
Roger that. And then we're just going to run a bunch of pages through, and you can just leave them in the hopper there.
Okay.
And Challenger Houston, we're about to go LOS. Mila will keep trying on TDRS, but we'll have Ascension UHF at 0 plus 07.
Roger, Houston, and we're gonna go ahead and do the hot fire test, and we'll report to you.
Roger, thank you.
This is Mission Control, Houston. We have intermittent communications through the tracking data relay satellite.
Challenger Houston with you on TDRS.
Roger, Houston, loud and clear, and we're on page 10-2, just getting ready to start on the THC pulse.
Roger, copy. And if we do lose TDRS, Ascension's UHF is down, so we'll see you Botswana at 0 plus 17.
Okay, understand, and tell Inco that the tags has been open for 1 minute and closed, and he can send up his commands.
Roger, copy, Dale. Thank you. And Challenger Houston, we'd like you to go ahead and turn the TAC hands off now that that test is complete.
Challenger Houston, we have you through ascension for about 6 minutes. Roger, copy. Challenger Houston.
Roger, go ahead.
Roger, you can go ahead and turn off the TACANs now that the test has been completed.
Roger, Houston, thanks for the reminder.
Roger. Challenger Houston. Roger, we'd like to see if you could reinitiate the maneuver in auto.
Now, Houston, I just noticed that in just 30 minutes we're going to go to the EOIM attitude. Do you want us to go to make both maneuvers or just go there early?
Roger, Dick, you can go there early.
Roger.
And Challenger Houston, we're going LOS about 15 seconds, and we'll see you at Botswana at 0+17. Challenger Houston, we have you through ascension for about 6 minutes. Roger, copy. Challenger Houston.
Roger, go ahead.
Roger, you can go ahead and turn off the TACANs now that the test has been completed.
Roger, Houston, thanks for the reminder.
Roger. Challenger Houston. Roger, we'd like to see if you could reinitiate the maneuver in auto.
Now, Houston, I just noticed that in just 30 minutes we're going to go EOIM attitude. Do you want us to go to make both maneuvers or just go there early?
Roger, Dick, you can go there early.
Roger.
And Challenger Houston, we're going LOS about 15 seconds, and we'll see you at Botswana at 0+17.
Mission Control Houston, standing by for acquisition through Botswana.
Challenger Houston, we have you through Botswana now for about 6.5 minutes, and we have an exact time for that tail glow maneuver.
Roger, Houston, go ahead with the time for the tail glow maneuver.
Okay, the plan is as follows. We'd like you to initiate the maneuver at 5 days, 2 hours and 27 minutes, and then the photo opportunity will go from 2+31 to 2+51. And as soon as that photo opportunity is complete at 2+54, we'd like you to go right into the TDRS side lobe test that was scheduled for 3+55. Basically, we're just going to do it 1 hour earlier.
Okay, we copied all that. Sounds like a good idea. Thanks.
Roger that. Challenger Houston, we're about 45 seconds to LOS. We'll see you next at Guam at 0+49.
Okay, thank you, Houston.
Mission Control Houston, 5 days, 0 hours, 23 minutes mission elapsed time. Challenger is passing out of range of the Botswana station, and we'll have a long loss of signal period of about 25 minutes before we pick up over Guam. And that would be on orbit number, just at the start of orbit number 82. Crew reported earlier that they completed the reaction control system hot fire test. They're running through a series of vehicle checkouts and other experimental objectives this morning. This is mostly a prepare for coming home day. Crew's activities for the remainder of the day are primarily cabin stowage, having already completed the flight control system checkout earlier today. This is Mission Control, Houston.
Challenger Houston, we have AOS through Guam for 5 and for 6 minutes.
Roger, Houston. And Franklin, can you tell us what the MET is that you're going to want the VTR dump of the RMS survey of the underside of the vehicle?
Stand by, Dan.
Okay.
And Challenger Houston, we got an answer on the VTR time.
Okay, go on, Franklin.
That will be at 2 plus 37 over Hawaii, by 1 rev from this one.
Okay, understand. Thanks a lot.
And Challenger Houston, we got a couple of item entries on Spec 22.
Stand by, Franklin. Hey, Franklin.
Okay, on that Spec 22, the -Z Star Tracker shutter to auto, that's on item 16. And we'd like to get the tracker back to track after that's done. And we'd like to verify the EOIM activation.
Okay, Franklin, that's firm.
Roger that.
And Houston CDR, I'm sorry, I did not activate the EOIM. I'm doing it right now.
We copy, Challenger. Challenger Houston, we're going LOS. We'll see you next at Hawaii at 1 plus 02.
I just stay in Hawaii.
Mission Control, Houston. We have loss of signal through Guam, and we'll pick up again in about 6 minutes and 6.5 minutes through Hawaii.
Challenger Houston, we have you through Hawaii for about 6 minutes.
Houston, and you're breaking up again.
Say again, Columbia, you were broken.
Okay, that transmission was loud and clear, Houston. The first one you made was very broken.
Okay, you're loud and clear now. Challenger.
Roger, Franklin, thanks. Houston, Challenger.
Go ahead, Challenger.
Roger, I'm looking through the light intensifier on the RMS glow experiment on the chevrons on the arm, and the arm itself and the two silver and the gold chevron all have about the equivalent amount of glow, but the black one has at least twice or probably about 3 times as much glow above it as the others.
Houston, copies. Challenger Houston, we're going LOS in about a minute. We're going to try TDRUS. If not, we'll see you over Buckhorn at 1 plus 12.
This is Mission Control, Houston. 5 days, 1 hour, 9 minutes mission elapsed time. Challenger beyond the range of the Hawaii station, orbit 82. We'll pick up again in about 2 minutes and 40 seconds during the pass over the continental United States. In that last communication, pilot Dan Brandenstein talking about the glow experiment. They are observing the interaction of the oxygen molecules at the altitude at which the orbiter is flying as they strike various structures on the orbiter, including the tail, the OMS pods, and the remote manipulator arm. The orbiter is at an altitude of about 120 nautical miles high. Typically, we have flown the spacecraft at around 160 nautical miles for most missions. However, about the second day or third day into the flight, we lowered the orbiter's altitude down to 120 nautical miles for the purpose of encountering the greater density of the random oxygen molecules that do exist up above the Earth's atmosphere. It was noticed on earlier shuttle flights that in some photography, time-lapse photography that the crew was doing, or long exposure photography, that there was a glow present around the tail, and it was later postulated that that was due to the oxygen molecules impacting on the orbiter structures. So this test is one to observe the glow that occurs when that happens. We have also been exposing some materials in the cargo bay to the oxygen molecules. That's another reason for flying at that altitude. We're about 50 seconds away from reacquisition over continental U.S. through the Buckhorn station. 5 days, 1 hour, 11 minutes mission elapsed time. This is Mission Control.
Challenger Houston, we have you through TDRS for 43 minutes.
Roger, Houston, read you loud and clear.
Houston copies. Challenger.
Okay.
Challenger Houston, we had a momentary drop in comm. We're back with you on TDRS.
Roger, loud and clear. Houston, Challenger.
Challenger Houston, go ahead.
Okay, we finished up the first part of the glow stuff with the RMS. We ran through the sequence on the RMS, on the EOIM pallet, on the OMS pod, and then Jeff had requested that we go off and shoot a star. We got the Constellation Cassiopeia, and we ran all those through that same sequence. And now we're going to set up for the next night pass and do the with the grading on.
Houston copies. Challenger Houston, how do you read?
Loud and clear now, but for a while I guess we dropped out.
That's a firm, Dick, and we have about a 2.5 minute pass, and we have a quick note to send up to you which relates to the cabin pressure, if you're ready to copy.
Okay, ready to copy.
Roger, we're going to have to do a cabin repressurization at Guam at about 2+23, and the reason for that is that the System 1 and 2 regulator is a bit sluggish. We're seeing a slight drop in pressure sufficient to give an O2 flow alarm. We'd like to swap systems and see if this is a pressure problem, regulator unique problem, or a normal system phenomena. The only change to the orbit ops checklist on page 5-10 is we'd like the on panel L2 the O2 N2 controller valve system 1 to close and 2 to open. And we'd like you to use system 1 first to pressurize with O2, and then system 2 to pressurize with N2. Do not inhibit the O2 and N2 flow parameters. Expect a high flow, caution and warning alarms during repressurization. And after you're through with the repressurization, we'd like you to return to the nominal O2 N2 controller configuration. And Challenger Houston, we're going to go LOS in about 30 seconds here. We're going to see you next at Botswana at 1+52.
Okay, fine. When we get to Botswana, I'll read it back to you, make sure I understand for the Guam test.
Roger that, Dick. Challenger Houston, we have you through Botswana for 6 minutes.
Roger, Houston, loud and clear. And let me read back this ECLS procedure, if I may.
Roger, we're ready.
Okay, over Guam, when we have data at 2+23, we're going to do a manual repress, except on panel L2, let's see, we're going to close the O2 N2 controller number 1 and open number 2. And then that means that when we press with O2, we'll use System 1, and then when we press with N2 per the procedure, we'll use System 2. And then, and during the test, we will not inhibit the O2 and N2 flow parameters, 24 and 54. Is that Charlie?
Roger, Dick. That's we concur.
Okay, we'll be ready at Guam to do that. What if I can ask you a question about a photo setup?
Go ahead.
Okay, back on STS-2, when we were doing our lightning work, there was a setup for the 70 millimeter Hasselblad to open the lens setting and record lightning flashes at night. And I don't remember it, nor do I have it on board. And I was wondering if you could check with Fernando Ramos or one of those guys that might have that f-stop and settings in the procedure and read it up to me later on, because we have seen a tremendous amount of around the world of night lighting, and I thought we could get a little small amount of that data.
Roger, Dick. We're looking into it. We'll get back with you.
Okay, thanks a million. Appreciate it.
Houston MS-1.
Go ahead, Challenger.
Yeah, I've got the information on the tags if you want it now.
Go ahead.
Okay, I just went down and checked the paper tray, and we had 14 sheets in there. This is post opening up the thing to expose the paper. And it looks like the developer is working, because the first sheet out is black, and then they get progressively gray until about the 10th sheet is white, and they're all white after that.
Roger, Dale. We copy. Thanks for the data.
Okay.
And Challenger, in order to regain telemetry, we're going to need a panel command switch action. And this will be sometime before Guam.
Whoops, I just did it.
Challenger, Houston, did you copy the panel command message I just gave you?
Houston, Challenger, affirmative, and I did answer, and I did do the panel in command.
Okay, thank you. And Challenger, Houston, we're going LOS. We'll see you at Guam 2+23, and your go for the APU cool off.
Okay.
Mission Control Houston, 5 days, 1 hour, 58 minutes, mission elapsed time. Challenger out of range of the Botswana station. And we're about 24 minutes from picking up again over Guam. This is Mission Control Houston.
This is Shuttle Control at 5 days, 2 hours, 10 minutes mission elapsed time. The change of shift briefing scheduled for 4:30 a.m. Central Daylight Time has been canceled. To repeat, the change of shift briefing scheduled for 4:30 a.m. Central Daylight Time has been canceled. This is Shuttle Control. The change of shift briefing previously scheduled for 5 a.m. Central Daylight Time has been canceled. This is Shuttle Control, 5 days, 2 hours, 22 minutes mission elapsed time. Guam will have acquisition of Challenger in about 15 seconds.
Challenger, Houston with you through Guam for 6.5.
Roger, Houston, and I need to talk to you. We've had a redundant set split, and over.
Roger, copy. We'll be looking at the data here in a second.
Okay, while you're getting the data up, let me tell you what happened. GNC wasn't doing anything except cooking along. The first message detected by both GPCs was a GPC byte on number 1. And on the same second, on the fault page, the set split. I have, since no jets are firing and we were just about to come up on Guam, I have elected to not take GPC-1 to halt. Both GPs are still in run, and it looks like a pure set split to me.
Okay, copy. Standby 1.
Roger. Houston Challenger, you still there?
Roger, we're still with you for another 3.5. DPS is still looking at the data, Dick.
Okay. We also, in the middle of all this, as it might happen, we tripped the lower limit on the cabin pressure alarm. Dan lowered it by 1/10 of a volt just so we could turn off the caution and warning, and the set split happened in the middle of all that. I would just as soon go ahead and repress the cabin per your procedure so that we can get that out of the way and not have to work two things at once.
Okay, standby.
Okay, Dan can be doing that in parallel. He understands the procedure that you wanted, and I'll stay with you with...
Okay, and Dan's got to go ahead for that.
Okay.
Okay, Dick, on your GPC, what we'd like you to do is go to the orbit pocket checklist, page 3-10, first GPC fail, and consider the failed GPC as GPC number 1.
Okay, I'm turned to that page, and that's what I would have done had I not elected to come up with both of them still running, and I'll follow that procedure.
Roger, thank you.
Okay, Houston, in step number 7, want me to bring up the freeze drive? Or stick with GPC 2?
That's a negative, Dick. Do not bring up the freeze drive, and we've got about 20 seconds left here. We'll see you at Hawaii in 7 minutes at 2+37.
Okay, and I couldn't concur more. I'll see you there, and I'll bring you up to speed when we come AOS.
Roger.
This is Shuttle Control. Guam has loss of signal. During this pass, Challenger's Commander Dick Truly reported a redundant set split of the general purpose computers. That's where two computers assigned to the same activity disagree. GPC number 1 is considered the failed computer in this instance, and Truly is now performing malfunction procedures, troubleshooting that problem. Hawaii is the next station in 6.5 minutes at 5 days, 2 hours, 30 minutes mission elapsed time. This is Shuttle Control, Houston. This is Shuttle Control, 5 days, 2 hours, 36 minutes mission elapsed time, standing by for acquisition at Hawaii.
Challenger, Houston's with you at Hawaii for 6 minutes.
Roger, Houston, and we need to talk some more here.
Roger, ready to copy.
Okay, on page 3-10, let's see, got down to step 9er, and when I set up spec 0 to restring, an automatic spec 0 showed up on, when I did the Ops 201 Pro, an automatic spec 0 showed up on Ops 20 on each of the CRTs that I'm looking at that's in GNC. And the first time that I did a resume, it would not resume. And Dale and Guy and I, or Dan's working the cabin pressure, Dale and Guy and I were sitting here discussing about why this should happen, because I think on a normal ops transition, that's the last thing that happens if you're going out to two mass memories that are not there, but in this case, never should have gone out. At any rate, just before AOS, I decided to try another resume, and at this time I tried another resume, and sure enough, the the resume worked, and I'm now looking at the original display, which is a GNC System Summary 1, a display instead of a spec.
Roger, we copy, Richard.
All right, Dale corrects me. I said one thing wrong. When I did the second resume, I did resume down to the ops display and then later called up the system summary, so that was incorrect.
Roger, we copy, Richard.
So I'm not sure that I've just never seen that exact chain of events before, and I'm ready to press on or ask your advice.
Roger, Richard, we copy the late acquisition, and we'll be getting to you as soon as DPS has a recommendation.
Houston CDR, I have been able to go back to the auto DAP, and GNC apparently is controlling because jets are fired to return to the GOIM attitude.
Roger, we copy, Richard.
Houston CDR.
Roger, Richard.
The other thing that Dale and I have been talking about is, and I didn't think this was the case, was that if by chance, if we had Spec 0 up on both CRT 1 and 3 and a display above it, when we did the ops mode recall, we do not remember whether or not that automatically flushes displays. Which would explain the first thing. It would not explain, in our mind, why we did a resume on the CRT and wouldn't resume. But I cannot remember the answer to the business about the ops mode recall flushing flushing displays.
Roger, we understand, Richard, and we're with you with TDRS.
Good.
Richard, for your information, the experts say that an ops mode recall retains displays and specs, and we have looked at your situation, and we want you to proceed with the procedures.
Okay, we'll proceed with the procedure.
Roger that.
Let me make one thing clear, John, just so you'll know what the configuration was when I did the Ops 201 recall. I definitely did have a system summary display up on CRT1 at the time I did the Ops 201 Pro. And because I wanted to watch the strings as they got reassigned. And it definitely did get flushed when I did do the Ops 201 Pro.
Roger, Richard, we copy.
Okay, we're going to continue with the printed procedure, and I'm getting back into it in step 10.
Roger that.
Okay, Houston, we're in block 9 on page 5-45 of the MAL, and we're going to do a software dump of GPC2, if you concur.
Roger, Richard, we're ready for it.
And Houston CDR and SSR2 had asked for one of the ops recorders to be in record A, and since we're AOS, we got one in playback and two in standby.
Roger, we copy. One in playback, two standby.
Okay, now we see ops recorder 2 in record A, and we'll wait till it gets within the limits and start the dump.
Roger, Richard. Go ahead and start the dump now.
This is Shuttle Control. Dick Truly is continuing the malfunction procedures on general purpose computer number 1. That GPC-1 and one other computer were assigned to guidance navigation.
Houston, just want to make sure we do this right the first time. I'm showing it record A, track 4 reverse, and 23%, which does not meet the criteria on NSSR2.
Roger, we copy that, Richard.
Number 1 was one of 2 computers assigned to guidance, navigation, and control
Richard, we are
functions.
switching tracks for you.
In forward, 19%, we'll start the dump.
Roger, go with the dump.
The other computer is continuing to monitor and control that GNC function, and there's been no loss of that function. We'll stand by for further communications on the problem.
Okay, Houston, the dump is on the way. It's on ops recorder 2, track 5, running forward 26%, and the time started about 10 seconds ago.
Roger, we copy, Richard.
Okay, Houston, the software dump is complete, and we're moving into block 11 and going to hardware dump GPC-1.
Roger that, Richard.
Okay, Houston, the hardware dump has started. It's on ops recorder 2, track 5, moving forward. It started at 35% at a time of 2 hours, 53 minutes, and 15 seconds.
Roger, thank you, Richard. We copy.
Okay, Houston, according to the clock, we've a double dump of the pass GPC-1 is complete.
Roger, we copy, Richard.
Okay, Houston, we're in block 12 now and going to attempt a re-IPL on GPC-1 if you concur.
Roger, Richard, we concur.
Tell you one thing.
Okay, it's in work.
Challenger, Houston, just be advised we may lose voice. We're getting marginal attitudes.
Roger, I'm not sure I copied all of that, John.
Roger, Richard, we may lose voice with you. If we do, we will see you at Botswana.
Okay, Houston, if you're still there, I'm in block 13. And I'm assuming that you want us to go into, we have a choice of going into block 14 or 16. Do you have a vote?
Challenger, we'd like you to go to block 16.
This is Shuttle Control at 5 days, 3 hours, 11 minutes mission elapsed time. Data Processing Systems Engineer Michael Darnell reports that telemetry indicates that the malfunction procedure has been successful. GPC number 1 has been recovered and is back in the set and operating properly. This is Shuttle Control, 5 days, 3 hours, 25 minutes mission elapsed time. Challenger approaching UHF voice acquisition through Botswana.
Challenger, Houston, we're with you at Botswana for 6 minutes.
Roger, Houston, now me.
Roger, loud and clear.
Okay, John, we're back in good shape. We've got a GPC-1, went back into the set with by the book. Got all the blocks that I went through, and I think you know them all. After we went LOS, all we did was restring and bring GPC back in, and now we're essentially in the nominal configuration.
Understand, Richard, and it looks good to us as well.
Okay, one thing did happen that was slightly different than the way you had asked us to do it. We started getting PPO2 messages as the PPO2 slowly rose after we had the system secured. And I elected to, so we jacked up the PPO2 limits to 3.6 to quadrant end the system. And just so that I could work one problem at a time, I elected to close the WCS vacuum vent valve. So that's our present configuration. And
Roger, we copy, Richard.
Hours, if you'd like to reopen it and look at the configuration for however long you'd like, just let me know.
Roger that. It's not required, Richard.
Okay. Houston, CDR.
Roger, go, Richard.
Just a second. Stand by, please. Okay, on the wastewater dump, we delayed it. It was delayed a little bit because of the GPC stuff, and the WIS is in use, and so I'm just delaying starting the wastewater dump a little bit. Looking at the, well, first of all, let me tell you that on board the stowing situation in good shape. We did some of it, a good bit of it this morning, so we're in good shape configuration-wise from a crew systems point of view on board with regards to the cabin. And looking at what we had as a plan schedule, we've already got the tail glow camera set up, so if you can find a time we could go do the tail glow, we'd be glad to do that. And also I noticed that the maneuver to the teacher's side lobe test is still in front of us, so if you'll just take a look and tell us what you'd like to do about the maneuvers and that kind of stuff, we'll just go ahead about our business.
Roger, Richard. We will give you, we would like to do the tail glow next rev and continue with the teeterous side lobe test as planned.
Okay, then all I'll need is maneuver time and availability time, and we'll do it.
Roger that. And Challenger Houston, we're 1 minute to LOS here at Botswana. We'll see you at Indian Ocean in 4 minutes. And Richard, you can delete doing the visual acuity test now if you want, and get that activity when you want to. And as well on the HRM, you can do that activity when you would like, and we would like an hour and a half of data, and just record the times, please.
Okay, I think the HRM has already been activated. However, I didn't do it, so I don't know the times. That's no problem, and no problem on the visual acuity. We'll get all that stuff done, no problem.
Roger that, and we'll get you an attitude as you requested.
Okay, doke.
And Richard, we'd like you to get the APU-3 controller to off.
Okay.
This is Shuttle Control. Challenger has moved out of range of Botswana. Acquisition next through the Indian Ocean Station in 4 minutes. During this Botswana pass, Dick Truly confirmed that general purpose computer number 1 is back in good shape. Went back into the set by the book, he said. All operations normal. And he reported the cabin stowage situation is in good shape. That activity is scheduled for a good part of the day. We'll stand by for acquisition through iOS in about 3 minutes. At 5 days, 3 hours, 33 minutes mission elapsed time. This is Shuttle Control, Houston.
Challenger Houston's with you at Indian Ocean, and just a correction on what I told you going LOS, that was the APU-3 controller power to off.
That's affirm. I turned the APU controller power number 3 to off.
Roger, and we concur, Richard. That was just my mistake on the call. Challenger, Houston, we're going LOS here in 15 seconds. See you at Guam at 3+58.
Okay, Guam at 3+58.
Roger, and your configuration looks good to us all around.
Super, thank you, John, and we'll do the wastewater dump and be in good shape at Guam. See you later.
Roger.
This is Shuttle Control. The Indian Ocean Station has loss of signal with Challenger. Next station is Guam in 18 and a half minutes. At 5 days, 3 hours, 40 minutes mission elapsed time. This is Shuttle Control, Houston. This is Shuttle Control, 5 days, 3 hours, 58 minutes mission elapsed time. Challenger about 30 seconds away from acquisition through Guam.
Challenger, Houston with you at Guam for 3 minutes.
Roger, Houston, loud and clear, and I guess I was a little confused about the maneuvers, John. Tell me, I'm set up to do the maneuver to the TDRS side lobe test attitude. I'm about 2 minutes late. I'm waiting on you at Guam. Is that what you wanted me to do? If so, all I got to do is start.
Roger that, Richard. And you have plenty of time.
Okay, I'm starting the maneuver now.
And Challenger, Houston, INCO is going to be doing an NSP command, so you can ignore the message.
Okay, and the maneuver's in progress.
Roger. And Richard, we would like to have the VTR playback of the orbiter survey at Hawaii. So at AOS Hawaii, you could go ahead and start the dump. We'll continue with it through TDRS, and we will let you know when to stop. And just for your information, we will go ahead and do that side lobe test after the dump.
Okay, I understand. We'll be prepared at Hawaii AOS, and when you say you're ready, we'll start. All we got to do is hit one switch.
Roger, we'll do that.
And Houston CDR, on the wastewater dump, you want to dump it all the way, or would you like to stop it?
Roger, Richard, you have dumped enough. You can secure it now.
Okay. And now Houston CDR.
Roger.
Roger, the sun was setting, but we were interested in trying to see the cyclone in the Guam area. And about, I guess 3 minutes ago or so, we passed overhead the very edge of a tremendous area of clouds. It was solid. Looking down on it, it was almost looked like high cirrus as far as we could see into the night. And it was obviously embedded with thunderstorms because looking at the lightning, however, the sun angle was so low that we did not get any pictures of it.
Roger, we copy Richard, and we're going LOS here in 30 seconds. We'll see you in Hawaii in 8 minutes.
Okay, see you there.
This is Shuttle Control. Loss of signal at Guam. Next acquisition, Hawaii in 7.5 minutes. At 5 days, 4 hours, 3 minutes mission elapsed time. This is Shuttle Control, Houston. This is Shuttle Control, 5 days, 4 hours, 10 minutes mission elapsed time. Challenger coming up on acquisition through Hawaii with a handover to TDRS. We should get the videotape recorder dump started at Hawaii. This is the television through the end effector camera of the survey from yesterday of the bottom of the orbiter.
Challenger, Houston's with you at Hawaii for 6 minutes, and you can start the dump.
Okay, it's on the way.
And we would like a GNC Spec 1 for variable parameters, please. And we're getting good TV picture, Richard.
Okay, and CRT1 has your spec.
Thank you. And Richard, just for your information, GNC says your IMU-1 data looks real good to us.
Okay, thank you.
And I have your attitude and time for photo for the tail glow when you're ready to copy.
Just a second. Go ahead with the number.
Roger. Maneuver to the tail glow attitude and CRT1 is yours. Maneuver to the tail glow attitude with a target number 2, body vector 1, Omicron 270. Do it with the A1, Auto, Vern, DAP. Initiate track, 5 days, 5 hours, 10 minutes. Begin the tail glow photos during the photo opportunity between 5 days, 5 hours 32 to 5 hours 49 with a delta T of 17 minutes.
Okay, the attitude is 2, 1, and 270, A1 DAP. Initiate maneuver time at 5 hours and 10 minutes, and the tail glow availability time is 5 plus 32 to 5 plus 49.
That's a good readback, Richard. And just for your information, the important part of this experiment is the tail glow with the diffraction grating. It is optional for you to do the thruster firing part if you want to.
Look at that.
If you elect to do the thruster firing, we don't want it to interfere with the glow part of the experiment.
Stand by 1. Okay, John, we got plenty of time to do it as printed. We got enough film left to make it through that printed procedure once. If you would just like the first part of the procedure with the various camera settings instead of the jet firings, let us know. In other words, John, we intend to do the procedure as printed, and we think we can get both the exposures and the ones with the jet firings with no problem.
Roger, we understand, Richard, and if you have time to do it, payloads would like to have it.
Okay. Okay, John, in the picture now you're seeing the bottom of the starboard wing, and you can see that at various points we stopped and zoomed in just to get closer looks at various places.
Yeah, you really...
see one of the landing gear doors on the starboard main.
Roger, you really did a great job on all that photography, Dale, and your zooming in is really fantastic.
It was really fun for us to see. The bottom of the orbiter is not something that we have a chance to look at very much, and it was fun doing it.
Roger, and we're interested in any of your commentary on this.
We're also lucky that we ended up, we didn't have much time, but we ended up being on the daylight side with the sun angles good here, so we got a good view.
Roger.
Now I think we're going to pan to the left here, and we'll pick up the elevons. And GNC can look here and see where his elevons were placed today. There's the starboard. You can see the outboard one looks like it's trailed or up, and the inboard is down.
Roger, we see it now.
And I believe Richard zoomed in right here so you get a closer view of the inboard. How much more time we have, John?
Roger, we're about 20 seconds here to LOS Hawaii, but keep talking. We're going to try to pick up Teeters.
Okay. Maybe that was the body flap and the inboard on the starboard side. I'm not sure. And then we saw this little white streak out here, and I think in a little bit you'll zoom in on it.
John, we stopped the tape when we lost you. You ready to pick back up?
Roger, we are. We have a good lockup with Teeterus now.
And that was the body flap, and I guess that's the inboard on the port side, probably.
Roger. And we're getting another good picture now, Dale.
Great. Okay, now we go to the left, and there you see the tip of the port wing, and you notice, 4 or 5 feet in from the tip there's a small white streak, and here's where Richard tried to talk me into getting it centered into the frame, and I got into a reach limit, so you'll see me go back after that. Then we'll try to zoom in on that streak. There you can see it's not really anything important, just probably a streak caused by some gap filler.
Roger, we can see the streak, Dale, thanks.
And here's the orbiter doing a barrel roll.
Roger, and the Earth is going with it.
Because we're in my ZLV, John, the Earth's got to go wherever we do. You can see the port landing gear door again. The body flap. So it looks like both starboard elevons must be a little bit up because we can't really see them there in that view.
Roger.
And for those of you who aren't familiar with the RMS, what we've really done here is stuck the arm out, the upper boom out straight to the port, and then the elbow we bent down 90 degrees, and then the wrist bent 90 degrees in, and that allows us to see the bottom of the vehicle. And then using the wrist pitch, wrist yaw, and rich roll joints, we just try to get as many views of the bottom as we can. The sequence worked out real well. You can see we saw a good portion of the bottom of the vehicle. Now we're right at the end, and we're beginning to bring the arm back up to a point where we can put it back in the bay. And here you're seeing the top of the wing. Oh, we're having a little trouble with the VTR, John. Stand by.
Understanding, my Dale.
Okay, John, I guess what would happen is we'd switch to another tape at that point, and that one we've already stowed down in the return to Houston bag, but that was essentially the end of the sequence.
Roger, we appreciate the test, Dale. We have the data.
Okay.
And Houston CDR, I guess the only comment, an additional comment that I'd make to that RMS sequence that you saw was that as Dale positioned the arm, it was comfortable because between the eyeball view that we could scrunch up and get out the corner of the windows and the payload bay TVs, there was never any concern on our part that we were getting close to any part of the structure.
Roger that.
And John, since that's probably the end of PDRS and RMS talk for this flight, there's one guy I'd like to say a few words about, and that's Pramod Kumar, who's been there at JSC from up in Canada for quite a few years and is largely responsible for all the good stuff that we've seen from the arm over these T&E flights. I was a late comer to the RMS stuff, but I know Richard and all the rest of the guys that flew the arm on 2, 3, 4, and 7, and we on 8 really appreciate his efforts and wish him good luck back up in Canada.
Roger that, Dale, and you can go ahead now to the Teeterus side lobe test, please.
Okay, Dick and Dan are starting that up right now. Thanks a lot.
And Teeterus COM may be in and out the rest of the pass. If we do lose you and don't recover, we will see you at Botswana at 4 plus 59.
Okay, we understand, and Dick says we're at attitude now.
Roger, we will start the test.
Hey, John, stand by one. Richard's checking the attitude here again.
Roger that. We'll stand by.
Roger, John. I just had a start because I looked at the numbers and they didn't ring a bell, but I've rechecked them and we are, I'm showing we are at attitude.
Roger, and we concur, Richard. Your attitude looks good.
Okay.
INCO is starting the test.
And Houston Challenger, the remaining gas experiments have been deactivated, and I did get the HRM started, and I'll give you the time on that in a second.
Roger, Dale.
Okay, Houston, Guy activated the HRM at 5 days, 3 hours, and 15 minutes.
Copy, Dale.
And Houston CDR, just to confirm, with the tail glow now, the maneuver initiate being at 0510, I'm assuming as soon as we're through with the tail glow, you'd like us to go to the EOIM attitude.
That's affirmative, Richard.
Okay.
This is Shuttle Control. A playback of 27 seconds of tape showing Mission Specialist Dale Gardner in sleep restraint will be at 6:30 a.m. Central Daylight Time. This is Shuttle Control. At 6:30 a.m. Central Daylight Time, there'll be a tape playback of Dale Gardner in the sleep restraint aboard Challenger.
Houston Challenger, if you're trying to call, we hear keen, but cannot understand.
Negative, Challenger. We read you loud and clear, but we're not calling.
Okay.
This is Shuttle Control. 5 days, 4 hours, 59 minutes mission elapsed time. Standing by for acquisition at Botswana.
Challenger Houston, with you through Botswana for 6 minutes.
Roger, Houston, loud and clear.
Roger. Challenger Houston. Challenger Houston.
Roger, go ahead.
Roger, Richard. No hurry, but when you've got a minute, I've got a message on the way we're going to handle the lamp and fire suppression test, and also an answer to your question about lightning photography.
Stand by one. Okay, Fish, go ahead.
Roger, Richard, for the lamp and fire suppression test, where you wish to test the sensor A and Bay 3, so prior to performing that test, we'd like you to push in the circuit breaker, main B smoke detection breaker in Bay 1B 3A. Then we'd like you to perform the test. In post-test, we'd like you to again open that breaker.
Okay, understand.
Roger, and for the lightning photography, you'll have an option of using either the 70 millimeter or the 35 millimeter. If you wish to use the 35 millimeter, you can use the Photo TV checklist, page 3-15 for the setup. They prefer black and white photography, and you can use the f-stop settings that are given for day or night in the checklist. They recommend focusing at infinity and not using the intervalometer.
Okay, go ahead.
Roger, and for the 70 millimeter, you can open the f-stop since you have a slower film and set the speed for bulb and just push the shutter to determine the shutter speed, and if you are fortunate enough to catch some lightning, that should register on your film.
Okay, understand.
Roger, we're 15 seconds LOS. See you at Indian Ocean in 2 minutes.
Okay, we'll see you there.
Challenger Houston with you through Indian Ocean for 7 minutes.
Roger, Houston, and sound clear, and we've got the maneuver typed in to start to go to field below. That's 5 hours and 10 minutes.
Roger, we copy. Challenger Houston.
Go ahead.
Roger, we would like you to delay the glow maneuver until we give you a go.
Understand, delay the glow maneuver until when?
Until we give you a go from
Give me a go, okay.
Mission Control.
Okay. Houston, CDR.
Go ahead, Richard.
Roger, I wonder if I could get you to pass a personal thanks and also thanks and a thumbs up from the STS-8 crew to the folks that work the Indian Ocean Station. I understand this is the last mission they're going to support, but ever since STS-1, they've supported the shuttle in grand style, and we're up here looking out the window at the Indian Ocean, and we really appreciate their work.
Roger, Richard, and we at Mission Control certainly echo your appreciation. They've done a super job.
Super.
Challenger Houston.
Sir.
Roger, reference your attitude. We would like you to stay in your current attitude for orbit 85. This is so the ground can repeat the TDRS side-loading tests for one more rev. During that time, you should have available some stars of opportunity to enable the IMU alignment. And we would plan to give you a new time for initiation to the tail glow attitude on orbit 86.
Okay, Bill, that'll be fine with Dan and me.
Roger. Challenger Houston, we're 30 seconds LOS. See you next Hawaii at 5+45.
Roger, on the beach in Hawaii.
This is Shuttle Control. Indian Ocean Station has loss of signal. Next tracking station for Challenger is Hawaii in 30 minutes. About 28 and a half minutes. Challenger just beginning orbit number 85 at this time. At 5 days, 5 hours, 16 minutes mission elapsed time. This is Shuttle Control, Houston. This is Shuttle Control, 5 days, 5 hours, 44 minutes mission elapsed time. Challenger 30 seconds away from Hawaii AOS.
Challenger Houston with you through Hawaii for 6 minutes. Challenger Houston, I have the attitude for the tail glow when you're ready to copy.
Okay, Houston, we're ready to copy.
Roger, Dan. Your target will be 2, body vector 1, and Omicron 270. DAP will be A1 Auto Vern. Initiate track at 6+40. When your tail glow test is complete, you should return to the EOIM attitude.
Roger, and do you have the availability times?
Roger, Dan, your photo opportunity will be from 5 days, 6 hours, 59 minutes to 5 days, 7 hours, 19 minutes Delta time, 20 minutes.
Roger, we copy that.
Roger, Dan. And Challenger, Houston.
Go ahead.
Roger, Dan. Are you making any inputs to CRT4 at this time?
No.
Roger, Dan. You want to give your scratch pad line a check?
Okay, we cleared it.
Roger, Dan. We copy. Challenger, Houston. 40 seconds LOS. We'll try to reacquire on TDRS. The side load test may prevent us from getting you at AGO, and if we fail with TDRS and AGO, we'll see you at IOS at 6 + 42.
Okay, we'll see you there, and we're in the process of doing the annunciator and fire detector test.
Roger, Dan, we see that.
This is shuttle control. Hawaii has loss of signal. The TDRS testing may preclude voice communications from now until the Indian Ocean Station in about 49 minutes. Although there is a possibility we could talk to Challenger through the Santiago, Chile station in 19 minutes. And there's always the possibility of some voice through TDRS while the testing is going on. At 5 days,
Challenger,
5
Houston on
hours,
TDRS, how
53
copy?
minutes. This is shuttle control, Houston.
Houston, you're loud and clear.
Roger, Dan. You're loud and clear as well.
Houston, Challenger, both annunciator.
Challenger, Houston, back with you on TDRS. And Dan, you were cut out. Can you repeat your last?
Roger, just to let you know that we completed the annunciator light and fire detection test, and they both went good.
Roger, Dan, copy. Challenger, Houston.
Yeah, go ahead, Houston.
Roger, Guy. Your WCS vacuum valve's been closed for about 3 or 4 hours now, and we'd like to recommend that that valve be opened, and we'll give you a call on closing it.
Okay, we'll go ahead and open it.
This is shuttle control, 5 days, 6 hours, 41 minutes mission elapsed time. Challenger about 20 seconds away from the Indian Ocean Station.
Challenger, Houston with you through Indian Ocean for 5 minutes.
Howdy, Fish, loud and clear.
Roger, Dan. Loud and clear, you too. Challenger, Houston.
Go ahead, Houston.
Roger, Dan. Over on A7L, we'd like you to take the strain gauges to on so we can warm up the mads.
Okay, it's done.
Challenger, Houston, we're 30 seconds LOS. See you next, Hawaii at 7 + 20.
Okie doke, Bill. See you there.
This is shuttle control. Challenger is out of range of the Indian Ocean Station. Next acquisition will be through Hawaii in 31.5 minutes. At 5 days, 6 hours, 48 minutes mission elapsed time. This is shuttle control, Houston. This is Shuttle Control, 5 days, 7 hours, 20 minutes mission elapsed time. Hawaii is about to acquire Challenger.
Challenger Houston with you at Hawaii for 2 minutes, UHF.
Roger, Houston, loud and cleared. We've just gotten through taking the tail glow photography, and we're taking our notes, and we'll be maneuvering them to EOIM attitude.
Roger, Richard. We copy. And Challenger Houston, we're 30 seconds LOS. We'll try to reacquire TDRS. If not, see you next AGO 7+45.
Okay, Challenger, copy.
This is Shuttle Control, Hawaii has LOS. Dick Truly reporting they had completed the tail glow photography during just prior to AOS here at Hawaii. Next tracking station is Santiago in 21.5 minutes. We may acquire on TDRS prior to that time. We'll stand by.
Challenger Houston with you on TDRS. How copy?
Roger, copy loud and clear. And we got the tail glow stuff done. We're a little bit surprised. The glow was on the opposite side of the tail from what we'd been briefed and had the procedures written for, but we rotated the diffraction grating 180 degrees, got a good zero image and first order image, and proceeded with the test.
Do you know how much you'd like to dump the supply water this evening?
Challenger Houston, we copied Dan's message on the glow. You were cut out after that. Repeat.
Roger, I was just letting you know that the auto fuel cell purge has been
Challenger Houston back on TDRS. How copy?
read you loud and clear. How many?
Got you loud and clear this time, Richard. Could you just repeat your last?
Okay, the fuel cell purge is in progress. Could I have the numbers for the supply water dump? And do we need another manual cabin repressurization? And how about the IMU alignment?
Challenger Houston, that information's on its way up to you. We're going to have a Capcom change from Fish 2 to Fish 1.
Great.
Challenger Houston, we have your pre-sleep activities when you're ready to copy.
Go ahead, Capcom.
Okay, on your supply water dump, you'll be dumping tank Bravo to 30%. For your cryo heater configuration, O2 tank 3, heater A to auto, H2 tank 3, heater Alpha and Bravo, both of them to auto. And on your PCS cleanup, we want to take the O2 N2 controller valve, system 1 to open, system 2 to close, and that is to get the valves back in the correct configuration for the manual repress, which will be done tomorrow. And finally, the vacuum vent valve in the WMS, take to close.
Capcom on that transmission.
See if I got all that right. The dump tank Bravo to 30%. On the cryo, it's O2 tank 3 Alpha to auto, and H2 tank 3 Alpha and Bravo to auto. Vacuum vent valve close. And on the PCS system, we'd like to move change the O2 into system 1 controller to open, system 2 controller to close. But that's in preparation for a manual repress tomorrow and not one tonight. Is that correct?
That's correct, Challenger. Good read back, and we'll get back to you on the IMUs.
Great. How you doing? Is it night or morning? I've lost track of what time it is in Houston.
It's 9:08 a.m. here.
Well, good morning.
Good morning to you. And Challenger Houston, in answer to your question on IMUs, you can torque the values for stars 43 and 45 in the table. Go ahead. Challenger Houston, go ahead.
Challenger, how do you read?
We read you loud and clear.
Challenger, how do you read?
We read you loud and clear. Richard, how do you read?
Okay, we didn't hear you. Did I understand stars 43 and 45 in the star table are okay to torque the platforms with?
That's affirmative, Richard.
Outstanding. Okay, thanks a million.
This is shuttle control, 5 days, 7 hours, 45 minutes, mission elapsed time. Challenger moving within range of the Santiago, Chile station.
Challenger Houston, we copy.
Roger. Okay, in between Dan and me, looking out the window at the snow over the Andes, I think we've done everything you asked. I've torqued the platforms, we got the PCS system switches set, vacuum vent valve is closed, the supply water dump should be in progress, and the cryo heaters have been thrown. So you might take a look at our configuration.
We copy. And configuration looks good to us.
Great. I'm assuming you don't need the IMU numbers.
We do not need the IMU numbers, Richard, but we would like you to take the star trackers to track.
Oh dear, okay.
And Challenger Houston, we would also like you to take the primary RJDs to off.
Roger, we're not completely through with the pre-sleep activities, but we will get them. We also haven't changed the allow, but we'll get it.
Okay, we copy, Richard.
Okay, Houston, the drivers are off, and have you heard any preliminary conclusions on the GPC?
Okay, Richard, we copy, and we don't have any information right now, but we'll have it before you go to sleep.
Super, okay. Well, I'd like to, whatever things you think are going to be going on.
Challenger Houston's with you through Cedrus. We lost you there for a minute. Could you repeat your last, Richard? Challenger Houston's with you through Cedrus. How do you copy?
Roger, Houston. Richard's downstairs now, and he hasn't called you recently.
Roger.
Mustn't have been very important.
Okay, and in answer to your question for the GPC problem, what we think we'll be doing tomorrow is that we'll be putting string 4 on GPC 1 and string 1 on GPC 4, but we'll get back with you on the final answer on that a little later. And Challenger Houston, when one of you has a few spare moments to help us troubleshoot the problem you had with the resume, could we have one of you give a short narrative of your steps and observations from the time you did the ops mode recall?
Okay, Anna, this is Dale. Let me see if I can reconstruct it. We had, don't know what was up on CRT2, but I'm pretty sure it was not, we're pretty sure it was not Spec 0. On CRT1, Richard had put up System Summary 1 so that when he did the ops mode recall, we could see all the M's go away to ensure that GPC2 had picked up all the strings. He did the ops 201 Pro, and I looked away, but Richard said that it occurred and he saw the M's go away in System Summary 1, but when I looked back, I saw Spec 0 on both CRT1 and CRT2. And we talked it over a little bit, couldn't understand why that was the case since all we had done was restring. So Richard did a resume to CRT1 and nothing happened. And at that point we decided to keep our hands off the keyboard because we weren't sure what the GPCs were doing. And after 3 or 4 minutes, just before we came AOS at, I think it was Hawaii, Richard tried to resume again, and universal pointing came up. And from that point on, everything was nominal.
Okay, we copy. Thank you. Challenger Houston, go ahead.
Very clear and loud and clear. One of the things that is unusual about it as compared to the other modes, though, is when you lock up and when you brake lock, there's absolutely no indication on the airwaves that anything has changed about the comm. So on board, sometimes it's total silence and we think you're there and you've broken lock, or the vice versa is true. We've been LOS and you come AOS, and if you haven't made a call, we don't know it. It's not a big thing, just a characteristic of the system that's a little bit different than the S-band and particularly the UHF.
We copy. Thank you.
Okay, doke.
Challenger Houston, we are 2 minutes to TDRS LOS, and we'll see you again at Guam at 8+41.
Okie doke, we'll see you there. We're all eating our supper and looking out the window and just talking about spaceflight.
Sounds like fun.
This is shuttle control. We've had loss of signal through TDRS. Next acquisition through Guam in 27.5 minutes. At 5 days, 8 hours, 14 minutes mission elapsed time. This is shuttle control, Houston. This is shuttle control, 5 days, 8 hours, 41 minutes mission elapsed time. Challenger coming up on acquisition through Guam.
Challenger Houston, we're with you through Guam for 5 minutes. Challenger Houston, we're with you through Guam for 5 minutes. Challenger Houston, with you through Guam for 4 minutes.
Roger, Houston, we're reading you loud and clear. We have to change the batteries down here. We'll be right with you.
Roger.
Houston, CDR.
Challenger Houston, go ahead.
Roger, I just terminated the water dump, and apparently I made a mistake in setting the parameter because I dumped too much water out of tank Bravo. It's indicating about 9%. It was my mistake, but I guess you're going to have to recalculate your water management based on that, and my apologies.
We copy.
And Houston, CDR radio check on the other speaker. How do you read?
We read you loud and clear. How me?
Loud and clear here also.
Challenger Houston, we are 30 seconds to LOS. We will attempt TDRS, and if not, we'll see you at Santiago at 9+19.
9+19 at Santiago if we don't hook up with the TDRS. Okay, see you there.
This is shuttle control. Guam has LOS. TDRS AOS in 10 minutes, 20 seconds. If that is unsuccessful, the next station is Santiago in 31.5 minutes. At 5 days, 8 hours, 48 minutes, mission elapsed time. This is shuttle control, Houston. This is shuttle control, 5 days, 8 hours, 59 minutes, mission elapsed time. We have TDRS AOS.
Challenger Houston, with you through TDRS.
You were kind of weak. Say again, please.
Yeah, Richard, we were just telling you we're with you through TDRS, and we have 4 questions in regards to the problem with the resume key when you get a chance.
I'm sorry, you were too weak. Say again one more time, please.
Okay, we have 4 questions in regards to your problem with the resume key when you have time to answer.
Okay, we're all... Houston Challenger, we're ready to take your questions. Go ahead.
Okay, the first question is, were both resumes done from the same keyboard?
That's affirmative on keyboard number 1.
Okay, we copy. Second question is, did the major mode display appear on both CRTs, 1 and 2?
It is affirmative.
We copy. And third question is, what GPCs were assigned to CRTs 1 and 2?
Okay, GPC 1 was assigned to CRT 1 and GPC 2 was assigned to GPC 2.
We copy. And the final question is, what were the positions of the major function switches for CRTs 1 and 2?
They were both in GNC.
We copy. Thank you very much.
Houston, CDR.
Challenger Houston, go ahead.
Houston, CDR.
Challenger Houston, go ahead. We lost you there for a few minutes, Dick.
Okay, would you repeat question number 2 again, please?
Okay, question number 2 was, did the major mode display appear on both CRTs?
We're not sure that we understand at what point you're asking. Over.
Stand by. After the second resume.
Oh, okay. Let me go through the sequence. The first resume was a request to resume a system summary display from CRT1. And nothing, pardon me. GNC Spec 0 was sitting on both CRTs 1 and 2. The first to resume was a request to resume Spec 0 from CRT 1, and it was unsuccessful even though the resume word appeared on the scratchpad line. We thought at that time that the computers were the computer was hung up in some fashion that we did not understand. Several minutes went by and I attempted a second resume on CRT number 1, and that resume worked. And then I attempted a similar resume on CRT 2, and that resume worked, and from that moment till this, things have worked nominally.
We copy. Thank you very much, Dick.
You bet.
This is Shuttle Control. These questions concerning the GPCs relate to the redundant set split which occurred 6 or 7 hours ago. The computer experts on the ground are looking over the dump tape, telemetry from that, and are troubleshooting what the cause may be, and required some more information from the crew. Dick Truly went through a malfunction procedure and restored that computer, and it's been working fine since. We'll continue to stand by on TDRS.
Challenger Houston, we have some more info for you on the GPC-1 problem when you're ready to copy.
Roger, go ahead.
Okay, Richard, the best information we have now is that it's a hardware problem which caused a 1-bit error which resulted in the GPC byte message, resulting in the ultimate fail to sync. We think it's a one-time occurrence, and if GPC-1 continues to behave, we will use it as planned for entry tomorrow with string 4, and we will have some more information for you on the nightly system summary. Challenger
It's
Houston.
an MS3.
Roger.
Mary, do you want... Pardon me, Anna, do you want the DSO reports?
Yes, we do.
Okay, we continued on mission day 6, the fluid collections, processing. We worked with some equipment from MIT, the Palo Monitor, also monitored overnight, ambulatory recording, COG, heart rate, blood pressure, etc. We did leg photos from the crew, also did leg volumes with the stockings on the crew, did a bit of tissue tonometry, and did some impedance studies, and the times on those for is 050100. That's 5 days, 01 hours, 00 minutes, to 01 hours, 15 minutes. There were some rather lengthy and extensive studies prior to that on thresholds and VORs that were both angular and linear. And I think that about wraps up what we did, other than packing up things to come home. Oh, one other thing, we did photo document all of the things that we've been doing today, both motion picture and still.
We copy, Bill. Do you have a status on the animals?
Yes, they seem to have adapted to weightlessness surprisingly well, and are scurrying around the cages in a pretty skillful fashion. It's quite different from when they first appeared, and they remain surprisingly clean, healthy, every one of them, and show all signs of good health. They are maintaining their grooming, very active. Frankly, I was rather surprised at the appearance of them. They, as far as I can tell, are in extremely good condition. They still have some potato left, but it's good that we're coming home tomorrow, I guess. There's adequate food for them, though.
Okay, we copy. Challenger Houston, we're with you through Santiago for 4 minutes.
Roger, Houston, loud and clear.
And Challenger Houston, we'd like you to check teleprinter message number 45.
Houston, CDR, there's no message at all in the teleprinter, over.
Challenger Houston, that's one of the messages that came up first thing this morning when you woke up.
Okay, say again the number.
45.
And Houston, well, I'm looking for that teleprinter message. I understand Franklin was down at Santiago, and we've been watching the local countryside from straight above. As a matter of fact, right now we're looking down at the snow, and just thought we'd wish them down there, wish everybody down there a good word for the great work they've been doing.
Roger, we copy, and forget message 45.
Okay.
And Challenger, we're with you through Tidris. Challenger Houston.
Houston, Challenger, you call?
Yeah, we just want to let you know we're about 8 minutes from TDRS LOS. Your configuration for sleep looks good to us here on the ground, and since this is the last shift that you'll be working with the Crystal team, on behalf of all of us here at Mission Control, we'd like to congratulate you all on another outstanding day and on a superb mission overall. We'd like to tell you to get a good night's sleep, and we're all looking forward to the shuttle's first night landing tomorrow.
Roger, Houston, and we'd like to say goodnight to the Crystal team, too. We've been working with you for a long time before the flight, and during the flight it's been our pleasure, and we're also looking forward to the night landing. So we'll see you tomorrow.
Okay, Roger.
Good night.
Good night.
This is Shuttle Control. The crew rest period has begun. Still 6 minutes left in TDRS acquisition on this orbit. Challenger has just started orbit number 88. We don't expect to talk to the crew again, having said goodnight to them, but we'll stand by and see if there's any more air-ground during this next 5.5 minutes. A shift handover in Mission Control will take place at noon Central Daylight Time. And Flight Director Harold Drawn will have his change of shift briefing at 12:30 p.m. Central Daylight Time in room 135 at the JSC News Center. Change of shift briefing with Flight Director Harold Drawn at 12:30 p.m. Central Daylight Time. At 5 days, 9 hours, 44 minutes mission elapsed time. This is Shuttle Control, Houston.
This is Shuttle Mission Control at 5 hours, 5 days, 10 hours, 24 minutes mission elapsed time. Handover in the Mission Control Center has occurred, and Flight Director Jay Green and the planning team have relieved Flight Director Harold Drawn and his team. And that, of course, represents the final shift of Harold Drawn's team, and they are exhibiting a great sense of release and relief in having fulfilled their portion of this mission. Challenger on orbit 88 just completed a pass over Guam. We're about 55 minutes into the sleep period, but the downlink indicates a couple of CRTs, cathode ray tube displays, are still on the pilot and commander's CRT, and one of the panels at the aft crew station apparently are still turned on, indicating that the crew hasn't gone to sleep yet. We'll have an LOS of a little over 20 minutes, and get another look at some of the downlink to get some idea of when the crew begins to wind down for the evening. At mission elapsed time, 5 days, 10 hours, 25 minutes. This is Mission Control, Houston. This is Mission Control, Houston at 5 days, 10 hours, 50 minutes. Mission elapsed time. We're taking data through the TDRS system presently, and the downlink shows the cathode ray tubes to be configured or to have been commanded to off position or into sleep configuration. Challenger on orbit 88, just approaching the west coast of South America. This is Mission Control, Houston. This is Mission Control, Houston at 5 days, 11 hours, 50 minutes. We just picked up data through Guam on orbit 89, and getting reassurance here in the control center that vehicle systems are untroubled and within nominal constraints. Data shows orbits of orbital parameters of 116 by 118 nautical miles, and that the crew is spending its last night in space apparently placid and uninterrupted. There are 5.5 hours remaining in the sleep period. This is Mission Control Houston. It's Mission Control Houston at 5 days, 12 hours, 51 minutes mission elapsed time. We've just completed a pass over Dakar on orbit 90. Everything remains quiet on board the vehicle. Cabin temperature shown to be 78 degrees and steady, humidity 27%. And no record of caution and warning alarms having occurred during any LOS period. And the crew's last night in space has been apparently restful and uninterrupted so far. This is Mission Control Houston. This is Mission Control Houston at 5 days, 12 hours, 53 minutes mission elapsed time. There apparently was a burst of interference on UHF, which apparently was transmitted over the air-to-ground loop and was audible here in the Mission Control Center. The ground control network officer traced it down to just a spurious UHF RFI, or radio frequency interference, which was local at the Dakar site where the orbiter just passed, and the GNC officer verified that it did not go up to the crew. This is Mission Control Houston. This is Mission Control Houston at 5 days, 13 hours, 55 minutes mission elapsed time. We're in the middle of a fairly long LOS period. Presently we don't require for another 22 minutes when we encountered Dakar. Challengers on orbit 91 over the South Pacific presently. As a note to news media representatives, the scheduled 8:30 change of shift briefing with Flight Director Jay Green will occur as scheduled. There will be no circumstances in which we cancel that. And any media representatives or network researchers or anyone who has or plans to have questions or inquiries about entry day activities should be advised that this will be their last opportunity to get their hands on a real live flight director and get those questions into a reliable source. Past experience has shown that a lot of people running around with questions 1 or 2 hours before landing, which is the worst possible time to get them answered, and to be well advised to prepare those questions early and get them into the flight director at tonight's briefing. Again, that briefing will occur as scheduled at 8:30 p.m. Mission elapsed time 5 days, 13 hours, 56 minutes. This is Mission Control Houston. This is Mission Control Houston at 5 days, 14 hours, 24 minutes mission elapsed time. We've just had a pass over the Dakar tracking station and picked up data for the first time in almost an hour, and systems on board the vehicle continue to look good. We've now shifted over to Tetris and are continuing to track through the satellite system. The mission control team is presently reviewing some messages for accuracy and clarity before they're uplinked to the crew, and these messages will constitute part of the Flight Day 7 execute package that will be uplinked to the crew, advising them of changes in the timelines and execute preparations in advance of deorbit and entry activities tomorrow. Just about 3 hours, a little more than 3 hours remaining in the crew sleep period presently. Challenger right now is on orbit number 91, just over the heart of North Africa. Mission elapsed time, 5 days, 14 hours, 26 minutes. This is Mission Control Houston. This is Mission Control Houston at 5 days, 15 hours, 35 minutes. Mission elapsed time. Challenger on orbit 92, just on an ascending node coming up toward Latin America, just on the off the west coast of South America. Right now crossing the equator at an altitude of 118 nautical miles. We're in the middle of another fairly long LOS period. We don't acquire again for another 17 minutes through Dakar, but there have been a number of TDRS takes during the LOS periods, and the mission control team has had frequent opportunities to look at downlink data. And there are an hour and 53 minutes remaining in the crew sleep period. This is Mission Control Houston. This Mission Control Houston, that's 5 days, 16 hours, 37 minutes mission elapsed time. Just about an hour remaining in the shuttle, in the crew's sleep period, and Challenger's on orbit 72, just acquired by the ground station at Arroyo Valley. And controller's getting a look at the data. It's a very brief pass of just over a minute, and a maximum elevation of 9 degrees over the horizon. And data indicates that all the onboard systems are healthy, and there have been no caution and warning alarms at any time during the night. Flight control team continuing to draft an execute package and prepare it for the onboard teleprinter to advise the crew of changes in their activity schedules in preparation for entry and landing tomorrow. At mission elapsed time, 5 days, 16 hours, 38 minutes. This is Mission Control Houston. This is Mission Control Houston at 5 days, 16 hours, 58 minutes mission elapsed time. It's about 31 minutes remaining in the crew sleep period. Nevertheless, CRT number 1 is turned on. Challenger's on orbit number 93, right over the South Pacific presently. But we're acquiring K-band data through the TDRS system, and able to look at the downlink telemetry showing that CRT number 1 is turned on. That's the cathode ray tube positioned directly in front of the commander's seat. So presumably at least Richard truly is awake on board Challenger. As a reminder to repeat earlier advisory, the 8:30 change of shift briefing with Flight Director Jay Green will be held as scheduled. And this will be the last time that the flight director will be available to the media before entry tomorrow morning. So any reporters or network researchers who have entry questions should take this opportunity to get their answers, because it's going to become increasingly difficult to find sources as entry time approaches. So the time is now to get your questions answered, and certainly not later. That change of shift briefing will occur on time at 8:30 p.m. Central Time in Building 2, Room 135. We have 30 minutes remaining in the crew sleep period, and although we have communications capability through the TDRS, and although Mission Commander Richard Julie is apparently awake, there are no plans to communicate with the crew until the sleep period has officially ended.
Good morning, Challenger.
Good morning. You've got everybody marching around up here.
Well, welcome to Entry Day. We're going to be proud to have you down here on a national holiday today.
Well, thank you. We're looking forward to it. Roger.
See you at Indian Ocean at 17 plus 46.
We'll go see you there.
And Challenger, Houston, we're with you now on TDRS.
Roger that. Roger that.
This Mission Control Houston at 5 days, 17 hours, 33 minutes.
Ron,
mission.
if you've got those notes handy, this would be a good time to pass them up.
Okay, first of all, on the manual cabin atmosphere management, we'd like you to repress with nitrogen only per the Orbit Ops checklist, page 510, just like yesterday and the day before. But there's a change. On panel L2, O2, N2 controller valve, system 1 closed, system 2 open. The rationale is that we did not receive data yesterday when this procedure was performed. If possible, we'd like to perform this procedure during a data pass, and we have good data now. Second thing on panel R1, cryo O2 tank 3 heater alpha to off. Cryo H2 tank 3 heaters alpha and Bravo 2 to off. And finally, we'd like you to clear the star table this morning to, in order to gather current stars. Possibility we may get Star of Opportunity IMU aligned.
Roger, the crow's done, the star table is clear, and I'm looking at the manual repress, see if I have any questions.
Okay.
It's Mission Control in Houston at mission elapsed time 5 days, 17 hours, 35 minutes. The wake-up call this morning was John Philip Sousa's Semper Fidelis, as performed by the Marine Corps Band. Significant in that the Capcom, Brian O'Connor, is a Marine Corps officer. And at the wake-up call, 3 of the cathode ray tubes were activated, and it was clear that the crew was up and around well in advance of the wake-up call this morning. We still have acquisition through TDRS. This is Mission Control Houston.
Challenger Houston with you on TDRS again. How do you read?
Roger, loud and clear, Brian, and your last transmission, if you continued it, was cut out.
Roger, all I said was check for stuck mic. We were getting a noisy downlink.
Okay. Houston, Challenger.
Go ahead. Go ahead, Challenger.
This is Mission Control Houston. Flight Director Gary Cohen and his entry team of flight controllers have begun to arrive in the control center and are tagging up with their counterparts in preparation for the handover scheduled for 8 o'clock. And again, we do intend to conduct the change of shift briefing with Flight Director Jay Green and encourage media representatives, network researchers to attend and get their entry day questions answered now, early on, since it's going to be increasingly difficult to take the time to run down data and sources as entry approaches. Again, that change of shift briefing is expected to occur on time at 8:30 p.m. Central Time in room 135 in the Johnson Space Center newsroom. At Mission Elapse time, 5 days, 17 hours, 42 minutes. This is Mission Control, Houston.
Houston, Comtech, Sunnyvale, Comtech. On air to ground 2.
Challenger, Houston with you over Indian Ocean for 6.5 minutes. Standing by.
Roger, Houston, loud and clear.
Read you the same. Challenger, Houston, we just lost S-band data. How do you read on UHF?
Loud and clear, Brian.
Roger, you the same. And Challenger, Houston, we've got S-band data back.
Okay.
Challenger, Houston, 10 seconds to LOS. We'll see you at Yarragadee at 18 plus 02.
Okay, 9 minutes at Yarragadee.
Challenger, Houston, standing by at Yarragadee for 7 minutes.
Roger, Houston, loud and clear.
Read you the same.
Houston, CDR.
Go ahead.
Roger, I guess y'all don't have data here, but the manual repress is complete within 2. And I'm not looking at the page number, but I did have one question in the deorbit prep. When we set up the DIPS config for deorbit prep, I was a little surprised, in addition to swapping strings between 1 and 4, that you also didn't swap the other things like CRTs and so forth.
Stand by. Challenger, Houston, Richard answered to your question about restringing.
Go ahead.
Roger, we think it would be reasonable to put CRT1 on GPC4 if you'd like to do that. Also, we were going to talk to you later about this, but in the same light, we think it'd be prudent to assign a downlister to GPC2.
Okay. I agree. It would be easier for me to remember just if we just swap the 1s and 4s, and I'd prefer to do that, and having the downlister on number 2, if that's what you'd like, is your call.
Roger, concur. And just a note, last time that we spoke, sounded like we got a lot of noise when Dale tried to talk. I'm not sure if he's got a problem with his key set or not.
Negative. He was using the same one that I had been using, and probably there was just something going on in the background.
Roger, the last few transmissions have been fine, no noise at all. And we're about to go LOS. We'll see you next at Auroral in about 2 minutes, 18 plus 11.
Roger that. See you there.
Challenger, Houston, with you at Auroral for 2 minutes.
Roger that, Brian. Loud and clear.
Read you the same, and we're standing by.
Okay, up.
Challenger, Houston, we're going LOS. We'll see you next at Tidris at 18 plus 25. If that doesn't work, we'll see you over the States at 18 plus 46.
Okay, Idris of the States. See you, Brian.
Mission Control, Houston. Loss of signal at Auroral Valley. Next station on the ground in 32 minutes will be Merritt Island
launch area, or Mila ground station, unless we do have TDRS lockup. And that's approximately 11 minutes away. Challenger now on nearing the end of orbit 93. The crew beginning to do the final stowage and preparation for landing tomorrow morning at Edwards Air Force Base. And some 4 hours prior to entry, they will switch from the crew activity plan in the flight data file to the deorbit prep handbook. From that to the entry checklist. In 5 days, 18 hours, 15 minutes, this is Mission Control, Houston.
Challenger Houston, with you, TDRS for 51 minutes.
Roger, Houston, and we need to discuss IMUs.
Roger, go ahead.
Okay, at a time of 1819, we got a BCE string 2 IMU. We deselected the IMU, tried an IO reset, no joy. Went to the MAL. In the malfunction procedure, page 523. Started in block 21. We went through block 22, 23, 24, 25. Stand by. 24, 26, 30, 32, and 35. In other words, we cycled power on the MDM, looked at the other port, and it looks like IMU 2 is down.
Roger, we're looking at the data.
Okay, and if you'd like to retry any of that while you have data, Brian, I'll be glad to. I wanted to go as far as I could before AOS just to give you as much head start as I could.
Okay, sir, we'll get back to you as soon as we can.
Okay, and Brian Guy says to pass on that the sun shield opened up nominally at 1825.
Roger, good news.
In Houston, CDR, we're going to delay stowing the KU band while your AOS teachers.
Roger. Challenger Houston, we'll probably go LOS for a few seconds while we switch over to KU.
Roger.
Challenger Houston, with you on KU band.
Roger, read you loud and clear.
Read you the same, and if you don't have anything else for us, the planning shift's going to sign off, hand over to the entry team. We wish you a good entry this morning.
Thank you, Brian, and thanks to the whole team. You guys have done a super mission for us. See you later.
Roger, good luck.
Challenger Houston, the entry team's with you, and we have a question reference your IMU2 alignment.
Roger, John, go ahead.
Roger, Richard, if you could just check spec 21 and make sure maybe you didn't inadvertently put IMU2 into standby.
When I first looked, well, first of all, the switch was not bumped. IMU2 switch is on. I checked it on, and it's still on. When I first looked at spec 21, I had a missing and a standby indication. I tried an hour reset, and there was no joy. We cycled power, tried an hour reset, and at that time there was no joy, and it was still in standby. I see now that it is back in operate, so I'm assuming that the power cycle on the MDM is what cured it.
Roger, we
and
copy,
IMU
Richard.
was deselected per the procedure.
Roger, we copy, Richard.
Does that answer your question, or am I going around it?
No, that's good. We'll see if GNC has another thought for you.
Okay, if I'm reading my data right now, looking at Spec 21, IMU is back in operation, and all we'd have to do would be to reselect it to get it back. I've got data on it. And Houston CDR, I was hasty in saying how good the IMU is. Obviously, the angles that I was looking at the delta X, Y, and Z, and not the angles. It looks like it may have caged itself and may need IMU to IMU line.
Roger. Okay, Richard, here is another question from GNC. At the time IMU-2 went down, we would like to know if Spec 21 was called up, and were you in the process of selecting an IMU for alignment?
Negative. As a matter of fact, I was shaving at the time. We got the message, and then I called up Spec 21 after we got the message to check it, and when I called it up, it was in standby.
Roger, we copy. Thank you, Richard. And Richard, we would like you to go ahead and do an IMU to IMU align using IMU number 3 as the good IMU, and align IMU 1 and 2 to 3. And then stop and let us look at the data.
Okay, I concur. We'll align 1 and 2 using 3 as...
And Richard, I copied align 1 and 2 using.
Roger, understand. We will, if I understand you right, we will align IMUs 1 and 2 using IMU 3 as a reference.
Roger that, Richard.
Okay, the line's in progress. The torque time was 18 plus 41 plus 10.
Roger, copy your torque time, Richard. And Challenger, Houston, if you need some more time to do the IMU align here, we can go ahead and delete the TDRS test maneuver. Your call.
Stand by one. I was just going to look at the update and see what our planned schedule was. Okay, Houston, I've done all I can do on the IMU to IMU align now. As a matter of fact, you just completed, so the IMU to IMU align is complete. I see we, and of course that wiped out any stars in the table. I'm assuming what you want us to do now is right away per your update is just go ahead and maneuver it and do this scheduled IMU align with stars 22 and 52, correct?
Stand by one, Richard.
Okay, the maneuver time is right now, so we need to decide to either go ahead and do it or not.
Roger, Richard, go ahead and maneuver to the IMU align at a 2.
I agree. Okay, Houston, the maneuver's in progress and the star trackers are in track mode.
Roger, we copy, Richard.
Don, I don't know. I've given you about all the data that I have. It looked to me like you may have just taken a power hit, a transient power hit, and recovered, but I don't know.
Roger, we copy, Richard. Richard, we think that is a possibility. We're going to do a playback and take a look at it.
Okay, doke. Just let me know and we'll press on.
Yes, sir. Challenger, Houston, you can go ahead and align per the procedure and the cap, but don't put 2 back in until we call you.
Do you understand? Concur. And Houston CDR, I was a little late, but high load duct heater's on.
Roger, copy, Richard.
And we picked up a couple of stars that are in the table now.
Mission Control, Houston. Change of shift briefing will start in about 4 minutes in the JSC briefing room, room 135, building 2, with outgoing Flight Director Jay Green. 4 minutes.
Okay, Houston. Star Trackers did it again. 22 and 52 are in the table.
Roger, we copy, Richard.
Okay, Houston, I'm going to torque at 18 plus 56.
Roger, your go, and we like your stars.
Okay, Houston, the star line is complete. And as far as I'm concerned, it's your call on this teacher's test. If you want us to go ahead and maneuver to that attitude now, we're on the way. Your call.
Roger, stand by 1, Richard.
Okay.
Challenger, Houston, your go. Stand by 1, Richard.
Houston, CDR, you were cut out. Say again.
Roger, Richard, I was starting to tell you something, and then I had to stop. Stand by 1, and I'll get back to you.
Okay, no problem.
Challenger, Houston, we showed that IMU 3 was not selected for the alignment, and we would like you to redo the star alignment with all 3 IMUs.
Shoot, you're right. And I'll do it. Stand by. Okay, the stars are back in the table. Looks like a better line this time anyway. And sorry about that, and I'll go ahead and be torquing in just a second.
Roger that, Richard, and we're your go for torque.
Okay, Houston, the line is complete. Tell GNC IOM1. And now it's your call on the teacher's attitude.
Roger that. Challenger, Houston, your go for the teeter's test attitude.
Okay. Okay, Houston, the maneuver is in progress, and now it's your call on the stowing of the KU band.
Roger, we copy, Richard. And Challenger, Houston, if you could put the star trackers back in track so that we can gather data, please.
Okay, they're there.
Challenger, Houston, you are go for EOIM deactivation.
Okay, Dan copies. Thank you.
Challenger, Houston, IMU-2 behavior looks very good to us now. You can reselect it, and just for your information, in about 5 minutes, we intend to give you a go to stow the KU band.
Thought you might say that. The payload bay lights are on and the cameras are all aimed to record on VTR.
Roger, Superdale. Challenger, Houston, we're not certain the first part of our last transmission was sent up to you. Just confirm for us that you copied to reselect IMU-2.
Negative, we did not receive that, but we do now, and we'll reselect IMU-2.
Roger that.
Okay, she's back in, John.
Roger that, Richard, thanks. Challenger, Houston, we're going LOS Teeters in 1 minute. You are go to stow the KU band in 3 minutes from now. Don't stow it until 3 minutes from now. We will see you at Indian Ocean at 19 plus 20 in 5 minutes.
Roger, understand. We'll stow the KU band after LOS. Thank you.
Roger. Challenger, Houston's with you at Indian Ocean for 6 minutes.
Roger, Houston, read you loud and clear, and we're in the midst of KU band antenna stuff.
Roger, we copy, Guy.
Houston, CDR, do you perhaps have an approximate take time?
Roger that, Richard.
Okay, thanks a million. Appreciate it.
Roger that. Challenger, Houston, we show the antenna is stowed. Thank you very much. And I have a note for you here when you're ready to copy. Reference your upcoming thermal test. Roger, Guy. During the sunshield opening, our data showed that the restraint index insert switch on panel L12 was in the inhibit position. And as a result, we recommend that when you do the first PAM ASE thermal test in about right now, in about 5 minutes, that you make sure that the restraint index insert switch is off before you do the SCA power down.
Roger, understand. Thank you, John.
Roger that, Guy. Challenger, Houston, we're going LOS here in 20 seconds. See you at Yargady at 19 plus 35.
Roger, Houston, we'll see you there.
Mission Control, Houston. Loss of signal at Indian Ocean Station. The KU band antenna on Challenger has been rotated aboard and into its stowed position for the duration of the flight. Crew proceeding with their pre-entry checklists, stowage. And the next station to acquire in about 6.5 minutes will be Yargady, Australia. On orbit 94 at 5 days, 19 hours, 29 minutes elapsed time. Mission Control, Houston.
Challenger, Houston's with you at Yargady for 7 minutes.
Roger, Houston, loud and clear.
And when you have a moment, Richard, I have 2 little flight notes for you.
And Houston, CDR, Dan and I are doing the red bypass fest checkout. We're in step number 5, and so far, so good.
Roger, copy that. And when somebody's ready to copy 2 little short flight messages, I'll send them up.
Okay, stand by 1. Okay, John, go ahead.
Okay, Richard, the first one back on panel A7, the MAD strain gauge to PCM enable.
Okay, you got it.
Thanks. And Richard, basically, the next one here, I'll give you all the rationale. Bottom line is we're trying to return the MTU accumulator 1 to that as our time source. The pass is currently on MTU accumulator 3 due to yesterday's redundant set split and today's IMU2 problem. As a result, we would like to return that pass to MTU accumulator 1 time. So over on spec GNC spec 2, if you would do an item 34 for us, please.
Okay, we did item 34, and the entire set is on accumulator 1 now.
Roger, we copy, and thank you very much, Richard.
You bet. Houston CDR.
Roger, go.
Roger, you'll be proud to know that the red bypass and fest checkout is complete and no problems.
Roger, we copy. And Richard, we're going LOS here in 30 seconds. We'll see you at Aurora Valley in a couple of minutes. If we don't get you there, we'll see you either with Teeters or Buckhorn at 20 plus 14.
Roger that.
Mission Control Houston, loss of signal at Yargity. A very brief pass upcoming at Aurora Valley, the final one of the mission. Maximum elevation a little over 4 degrees, and a very short pass of some 2 minutes. And following that, we should have Teeters acquisition in about 17 minutes. Meanwhile, here in Mission Control Houston, the weather office has completed their briefing, initial briefing to Flight Director Gary Cohen on end of mission weather at Edwards Air Force Base. The satellite photo of the western United States that was on the weather office display showed the entire California and western region severe clear with a thin layer of clouds offshore. And things look good at Edwards as far as wind conditions, predicted wind conditions at landing time tomorrow morning for a left-hand overhead approach to runway 22. Acquisition momentarily at Aurora Valley. Mission Control Houston at 5 days, 19 hours, 44 minutes.
Challenger Houston with you at Aurora Valley for a short pass.
Roger, Houston, loud and clear. And Houston CDR, we just got an S66 water message. Tank Charlie just tripped the 90% limit. It's indicating 89.
Roger, we copy. We copy, Richard. That's no problem. Normal FES usage. We're going LOS here in 20 seconds. See you with Teeters at 20 plus 00.
Okay, see you there.
Mission Control Houston. Ordinarily, we would have had acquisition through Teeters at this time. However, the prime computer at White Sands is being shifted over to the backup computer, which takes 15 or 20 minutes. We're configured aboard the spacecraft for Teeters acquisition. Therefore, Buckhorn in 10 minutes will not be able to receive data from the spacecraft or voice. However, at Merritt Island launch area in 15 minutes, we should be back in contact with Challenger. And hopefully by then, Teeters will be back online. This is Mission Control Houston, 5 days, 20 hours, 4 minutes. Mission Control Houston should be receiving downlink from Challenger at this time through Merritt Island launch area.
Challenger, Houston's with you at Mila and Bermuda for 10 minutes.
Roger, Houston, loud and clear. How many?
Roger, loud and clear, Richard.
In Houston, we're doing well on board the standby. And Houston CDR, things are going well on board. We've completed, we believe, all the actions in the cap, and we're just doing some final packing up and getting squared away to be ready to go in the deorbit prep on time.
Roger, we copy, Richard. Challenger, I have a change for you in the deorbit prep, FS1-3, when you're ready to copy.
Okay, John, ready to copy on 1-3.
Roger, Richard, up in the upper right-hand corner in the IMU star align attitude pad block. For star number 44, change the TIG minus 02 hours 11 minutes time to a minus 02 hours 13 minutes.
Okay, understand that star 44 closes at TIG minus 213.
Roger. And star 43 closes at TIG minus 0209.
Okay, star 43 closes at 0209.
Roger that, a good read back.
Okay, is that it?
Yes, sir.
Yes.
Challenger, Houston, we're going LOS in 18 seconds. See you at Dakar in 5 minutes.
Roger, John, see you at Dakar.
Mission Control, Houston. Loss of signal at Bermuda. Reacquisition through Dakar in 3.5 minutes, at which station the Mission Control Center will give a go for payload bay door closing. Commander Dick Truly reported at Merritt Island launch area pass that they were going to the deorbit prep checklist on time, had stowed the crew activity plan, and just prior to LOS at Bermuda, MCC passed up to the crew some new times for IMU star line attitudes, closing of when those stars would be visible to the star tracker. And on the subject of timing, accurate timing is taken for granted these days with quartz digital watches, atomic clocks in laboratories, and routine slicing of time into milliseconds and nanoseconds. The master timing unit aboard orbiter Challenger has a drift rate of less than 1 part in a billion per day. Not everyone has always demanded such exquisite accuracy in timekeeping. Joshua Slocum, in his book Sailing Alone Around the World, describes how he used an old tin clock bought for $1 in Yarmouth, Nova Scotia, to keep Greenwich Mean Time for computing his positions during the 3-year voyage. My tin clock and only timepiece had by now lost its minute hand, writes Slocum. But after I boiled her, she told the hours, and that was near enough on a long stretch. Acquisition coming up at Dakar in 1.5 minutes. Mission Control, Houston, at day 5, 20 hours, 33 minutes. Mission Control, Houston, we have acquisition at Dakar.
Challenger, Houston's with you at Dakar for 7 minutes.
Roger, Houston, you're loud and clear.
Roger, and you're loud and clear too, Dan.
Flight Director Gary Cohen polling the different console positions here in MCC for their recommendations of go for payload bay door closing. And it appears that all stations are go for payload bay door closing. Prior to LOS, the Capcom will pass that to the crew.
Challenger Houston, you are go for payload bay door closing.
Roger, Houston, thanks a lot. We're go for payload bay door closing.
Roger that.
And Houston CDR, we're going to put the caps up and start into the deorbit prep.
Roger, we copy. Challenger Houston, we're going LOS 30 seconds. We will see you at Yargity at 21 plus 09.
Roger, John. See you there.
Mission Control Houston, loss of signal at Dakar, at which the Mission Control Center gave the crew of Challenger a go for payload bay door closing. Truly reported that they had switched over to the deorbit prep checklist on board. Meanwhile, the ignition time for the deorbit burn has shifted some 30 seconds to an elapsed time of 6 days, 0 hours, 15 minutes, 30 seconds, with a delta V at 278 feet per second as opposed to 282. These times will likely shift back and forth as new vectors are computed over the next several hours. And we'll keep you posted on those changes. At 5 days, 20 hours, 45 minutes, and 24 minutes away from acquisition at Yargity. This is Mission Control Houston. This is Mission Control Houston. Teeters apparently is back toward the end of the acquisition area. The next several minutes.
Challenger Houston, we are locked up with you with Teeters now. Challenger Houston with you for 5 minutes with Teeters. How do you read? Challenger Houston's with you for 4.5 minutes. How do you read?
Roger, Houston, loud and clear.
Roger, Richard, we have a good Teeters lock here for about 4 minutes.
Okay, glad to have you.
And Crip, this is Houston. How do you read? Weather Flight Houston, how do you read? Weather Flight Houston, how do you read?
Mission Control Houston, port payload bay door is closed at this time. Mission Control Houston, loss of signal at the edge of the TDRS coverage. The port payload bay door was closed and latched prior to LOS at TDRS. And as we lost contact, the starboard payload bay door was coming closed. Next station in 13 minutes is Yargity, where we ought to get confirmation that both doors are closed and latched. 5 days, 20 hours, 55 minutes. This is Mission Control Houston.
Challenger Houston's with you at Yargity for 6.5 minutes.
Roger, John. And Houston, Challenger. We got the payload bay doors closed. They closed with 2 motor times all around, and they looked about as straight as an arrow just before the starboard door came closed.
Roger, we copy, Dan. Thank you very much.
Houston, CDR. Houston, CDR.
Roger, go ahead.
Roger, thank you for that excellent entry summary that you gave us on the teleprinter. There was one question that I had that was kind of implied but wasn't stated explicitly. What is the status of Lakebed 17 at Edwards?
Roger, stand by, Richard. I'll work up an answer for you.
Roger, no hurry, but that was an excellent summary. Appreciate it.
Roger, Richard, 17 is dry, usable, and in good shape.
Roger, thank you, John.
Challenger, Houston, we're going LOS in 20 seconds. We'll see you at Hawaii at 21 plus 35.
Roger, Houston, see you there.
Roger that, Dan.
This is Mission Control, Houston. Loss of signal at Yargity. Hawaii in 18 minutes. Over the last 20 years here in Mission Control, Eugene Krantz, the JSC Director of Mission Operations, has been a legend in his own time for his attire in brocade vests back when he was a flight director. Tonight he's wearing a red, white, and blue striped brocade vest. Next station, Hawaii in 17 minutes. At 5 days, 21 hours, 18 minutes, Mission Control, Houston. Mission Control, Houston. Acquisition momentarily through Hawaii.
Challenger, Houston's with you at Hawaii for 5 minutes.
Roger, Houston, loud and clear. We've got the alignment going to the verification now, and I've got the numbers if you'd like them.
Roger, ready to copy.
Okay, stars 4-4 and 4-3. The angle error was 0.2, 84.1 was the total angle. IMU1 plus 0.02, minus 0.01, plus 0.03. IMU2 minus 0.04, all balls minus 0.07. IMU3 minus 0.03, minus 0.03, plus 0.04. Torque time 24128.
Roger, we copy, Richard.
And Houston, Challenger, we had forward number 3 down jet fail with a leak. Went through the mal procedure, it auto deselected, and we're waiting for you to look at injector temps. Was during the maneuver, the IMU line attitude and the quantities in fuel and ox were not diverging.
Roger that, Dale. Stand by one. And Dan, we show that it is an oxidizer leak. There is no action. Leave it deselected.
Roll call.
Challenger, Houston, we're uplinking targets and state vector.
Roger, Houston. Houston CDR, the verification numbers look good. Are you looking at them?
Roger, stand by one, Richard. We're looking at them.
Okay, and if you don't have them, I do.
Richard, you can press on. The numbers look good to us.
Well, thank you.
Challenger Houston, the vector and targets are on board.
Roger, Houston.
Challenger Houston, we're going LOS in 30 seconds. We'll see you at the States at 21 plus 45.
Roger, and I'm assuming the burn attitude printed on page FS1-3 is okay to maneuver to.
Negative, that is not true, Richard. We'll send you a number.
Okay, I'll remain here till I talk to you again.
Mission Control Houston, LOS at Hawaii. 3 minutes to Buckhorn reacquisition.
Challenger Houston, with you on TDRS. We'd like a GNC Spec 1, please.
Roger, CRT 1.
Thank you, Richard.
You bet. How's it going?
Great. Got some great weather out there for you.
Super.
Challenger Houston, we've sent all of our teleprinter updates to you. We're through with the teleprinter.
Roger, understand.
Challenger Houston, the CRT is yours. Thank you.
Roger.
Challenger Houston, I've got your pads for you. Whenever you're ready, I'll have the Dell pad first, so it'll have your burn attitude at the top.
Okay, stand by. Challenger is ready to copy.
Okay, Dell pad on deorbit. Burn attitude 162, 091, 338. HA 118 by negative 022. 278.5, 2:31. Propellant, all balls. 6:00. 116. 116. Safe HP 90. 2337. 9147. Oxidizer 00. 1091.6. Negative 0.1. Entry landing. Inertial at 191, 291, 028. Pre-bank left, all balls. Guam AOS, EI minus 09. LOS, EI minus 03. Altimeter 29.76. Drag equal 400:43:17. 12700. Be a left overhead 202 degrees. Edwards 22. Winds 260/30. 270/25. 310/15. 310/10. 100/05. Surface variable at 05. APU start sequence 1, then 2. Note, you can down mode to RCS up to 2 minutes past TIG. Ready for readback.
Roger, starting from the top. 162091338. 118 minus 022. 278.5, 2:31. All balls 600-116-116. 90-2337 9147. 00 1091.6 minus 0.1. 191, 291, 028. Left 000, Guam 09er 03. 2976 004317. 12700. Left overhead 202, Edwards 22. 26030, 27025, 31015, 31010, 1005, and variable at 5, and start sequence is 1, then 2.
Roger, readback's correct. I've got the, and did you copy? You can download RCS up to 2 minutes late.
Oh yeah, I forgot to read that back. We're able to download to RCS at as late as tick plus 2.
Roger, readback correct. I've got your maneuver pad whenever you're ready.
Ready to copy.
Okay, be ohms both. TV roll 180 plus 0.4 minus 5.7 plus 5.7. 212335. TIG 006/00:15:30.0. Peg 4 targets 15448 minus 0.6211 065.832 096.344. All balls. Burn attitude 162091338 403120:22. And standby 1, we're dropping in and out on our S-band. Challenger Houston, how do you read me now?
Loud and clear, and start again at REI.
Okay, REI 403120:22. Delta V total 0278.5 02:31 plus 0268.55. All balls plus 073.90. HA 118 by minus 022. Ready for readback.
Oh, plus 5.7 plus 5.
Challenger Houston, we got intermittent lock, standby for the readback.
65.832, 096.334, 162, 091.338, 4031, 2022, 278.5, 2 plus 31, plus 268.55, all balls, plus 73.9er, 118 minus 022.
Roger, the part I heard was good. Richard, we picked you up at propellant. If you could start at the top and run me down through theta T.
Okie doke, ohms both, 180 plus 0.4 minus 5.7 plus 5.7. 212335 006 001530.0 15448 minus 0.6211 65.
Okay, we cut out again, Richard. I've got UHF now. If you could give me HT and theta T, please.
Okay, HT 065.832, theta T 096.344.
Roger, readback is correct.
Roger.
Houston, Challenger.
Go ahead, Dan.
Yeah, I have a question on page 1-11 in the recovery prep.
Roger, go ahead. We're looking at it.
Okay, down there under the main engine hydraulic repress prep on panel 017 row delta, both those lines start with if statements pertaining to 102. Does that mean we don't turn on either of our mechs?
I believe so, but stand by. Let me make sure.
Okay, I'd just like that verified, please.
You read that correctly, Dan. You can ignore those 2 steps.
Okay, thanks.
In Challenger Houston, we're about 20 seconds to LOS. Your go for Ops 3 transition, and we'll see you at Dakar at 22 plus 09.
Okay, see you there.
Mission Control, Houston. Loss of signal through Bermuda, Dakar, in 5.5 minutes. During the stateside pass, the deorbit maneuver pads were read up to the crew. The time of ignition, the attitude, burn time, all of the numbers the crew needs for setting up the orbit maneuvering system engines for the deorbit burn, which now is some 2 hours, 11 minutes away. Total reduction in velocity is 278.5 feet per second, which gives a theoretical perigee of 22 miles below the surface of the Earth, which of course brings the orbiter into the atmosphere and captured for deceleration, aerodynamic deceleration, and landing at Edwards tomorrow morning. Dakar in 4 minutes. At 5 days, 22 hours, 5 minutes. This is Mission Control, Houston.
Challenger Houston with you through Dakar and Ascension for 8.5.
Roger, Houston, and I'm in bubble 11. We just took GPCs 1 and 2 to Ops 3, and things are going normally.
Roger, copy. Challenger Houston, configure AOS. We've got 2 minutes left.
Okay.
Challenger Houston, we're 30 seconds to LOS here. We'll be handing over to Tidris.
Roger.
Challenger Houston with you to Tidris for 6.5.
Roger, Houston. Okay, Houston, the dips entry config bubble 11 is complete, no problems.
Roger, copy. And Challenger Houston, I've got a couple of steps I'd like you to pick up there in bubble 11.
Go ahead.
Roger, Dick. When you transition GPCs 1, 2, 3, and 4 to GNC Ops 3, down there at the bottom by CRT 3, the 4 steps for the BFS and the BFC, we need you to do those 4 steps. That's starting with BFS GNC Ops 000 Pro.
Okay, understand. Sorry, we missed those.
Roger.
Okay, Houston, we did that, and we dropped the targets when we did it, so we'll have to retype them or re-uplink them for us into the BFS.
Okay, stand by. And Challenger, we never did put them into the BFS, and we'll do that later.
Okay, Houston, thanks. Houston CDR radio checked on different comm configuration.
Richard, you're loud and clear.
Roger, understand. We're still operating for a few minutes on the speaker box, and I'm on my hard line now. We're going to go back to the original configuration, and we'll let you know when we switch back to hard line for everybody.
Okay, and we're sending the targets to the BFS right now.
Okay, thanks a lot. And if you'll bear with us, Dan and I are going to get off comm and go don our stuff, and Dale will be monitoring comm.
Okay, and the targets are in. And Challenger Houston, we're losing you on TDRS. Configure LOS. We'll have you on UHF through Botswana for another 4 minutes. And Challenger Houston with you on UHF through Botswana for 3.5. Did you copy my configure LOS?
Roger, configure LOS.
Thank you, Dale. Challenger Houston, we're 40 seconds to LOS. We'll see you at Yargadee at 22 plus 44. Challenger Houston, we'll see you at Yargadee at 2244.
Roger, see you there, guy.
Mission Control Houston, loss of signal at Botswana. Yargadee in 12 minutes. 1 hour and 44 minutes away from ignition and deorbit ignition. That will bring Challenger back into the atmosphere. Coasting toward the first night landing in the Space Shuttle program. Night takeoffs and landings have been routine in aviation for many years. In spaceflight, Apollo 17 was launched at night, and the Apollo 8 command module returned from a lunar orbit mission in the pre-dawn darkness to splash down in the Pacific. Challenger's night landing Monday at Edwards Air Force Base is expected to be routine also, with all the radio navigation aids and glide slope lighting aids available to the crew for lining up on final approach. Early aviators had to depend on unreliable wireless equipment and perhaps an occasional mountaintop beacon fire along the ground track. As aviation matured, beacon fires were replaced by electric rotating beacons and low-frequency radio beams with Morse code signals to tell pilots whether they were to the right or left or on the beam. In his short novel, Night Flight, French...
We never did put him into the BFS, and we'll do that later.
Okay, Houston, thanks. Houston CDR radio checked on different comm configuration.
Richard, you're loud and clear.
Roger, understand. We're still operating for a few minutes on the speaker box, and I'm on my hard line now. We're going to go back to the original configuration, and we'll let you know when we switch back to hard line for everybody.
Okay, and we're sending the targets to the BFS right now.
Okay, thanks a lot. And if you'll bear with us, Dan and I are going to get off comm and go don our stuff, and Dale will be monitoring comm.
Okay, and the targets are in. And Challenger Houston, we're losing you on TDRS. Configure LOS. We'll have you on UHF through Botswana for another 4 minutes. And Challenger Houston with you on UHF through Botswana for 3.5. Did you copy my configure LOS?
Roger, configure LOS.
Thank you, Dale. Challenger Houston, we're 40 seconds to LOS. We'll see you at Yargadee at 22 plus 44. Challenger Houston, we'll see you at Yargadee at 2244.
Roger, see you there, guy.
Mission Control Houston, loss of signal at Botswana. Yargity in 12 minutes. 1 hour and 44 minutes away from ignition and deorbit ignition. That will bring Challenger back into the atmosphere, coasting toward the first night landing in the Space Shuttle program. Night takeoffs and landings